Make sure that this isn't going to start playing on me all of a sudden. Go wait for the heads up from the chat room. Are we on? Are we ready to go? Getting the heads up from the chat room to know that we're good to start. We are live. So, starting the show in 3, 2. This is TWIS. This Week in Science, episode number 714, recorded on March 27th, 2019. What is the end? Hey everyone, I'm Dr. Kiki, and tonight on This Week in Science, we are going to fill your heads with new brain cells, lizard scuba, and space. But first,
disclaimer. The following program is not for the weak of mind, the bereft of imagination, or the willfully ignorant. If you consider yourself to be amongst any of those groups, you probably are not, as they never would be so self-aware as to think so. If you are the adventuring sort, an adventure here awaits as we go exploring into the unknown, following in intrepid footsteps of scientists the world over, and occasionally wandering off the path into the wilds of speculation and unknowns yet unknown. There are a few destinations where we have not dared to delve into, but subjects from astronomy to zoology, why the number of knowledge navigations we have neglected to navigate number in the, well, actually, it's a really big number still. There's more to know that can fit in a human skull. And on every extrascullular adventure, we venture together here on This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
and a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We're back again to fill your heads with everything that we want to talk about this week. So much happened this week. So we had to pick and choose the best parts. So here it comes, everyone. I have new stories about brain cells and exercise. And we have an interview tonight with the wonderful Dr. Katie Mack in a few moments. Justin, what did you bring?
I've got a ridiculous NASA warning and why evolution favors the nicheless, as well as, if time, cancer trees.
I hope we have time. I want to hear about cancer trees. Well, do I?
Is that a tree that grows cancer or a tree that cures cancer? See, we gotta find out.
We got an
Okay.
inquiring
I'll have
mind.
to add. I'll make sure this
Yeah.
story makes it by
Yeah.
the end. Yes.
Blair, what's in the animal corner tonight?
Oh my goodness. I have the underwater lizards you were discussing before. I have huge dinosaurs, and I have something about birdie motherhood.
Oh, I love bird moms
Mhm.
and dads. They're all
This is about the moms.
they're also tweets.
Oh.
Okay. Well, before we jump into the show, I would love to remind everyone that if you have not done so yet, you can subscribe to the This Week in Science podcast on YouTube. You can like our Facebook page, and you can find us all places that good podcasts are found. Pandora, Spotify, Spreaker, TuneIn, Stitcher, or just at twis.org. You can find lots of information there. And if you are in Portland, Oregon, next Wednesday, April 3rd, you can join us at the theater. We will be live at the Alberta Rose Theater in Portland, Oregon next Wednesday, broadcasting live. So those of you from out of town won't miss the show. We'll still be on air for you. But be ready. You can check our website for information. Okay, it's time to jump into our interview. I'm looking forward to this. Our guest tonight is Dr. Katie Mack. Katie Mack is a theoretical astrophysicist. She studies the universe from beginning to end, focusing on a number of questions on topics like dark matter, galaxy formation, cosmic strings, and much more. She's working on a book right now that's due out in 2020, calling it The End of Everything. I mean, then it's all over. It's 2020, the end of everything. Boom. And she recently published a study with Robert McNeese on micro black holes. Dr. Mack, welcome to the show.
Thanks. It's good to be here.
It's wonderful to have you on tonight to get a chance to talk with you about the end. I mean, so instead of starting at the beginning like we tend to do in our interviews, I'd love to start at the end and find out, how you got interested in the end of the universe.
So as a cosmologist, I studied the early universe for a long time, and all these big questions about kind of how everything fits together, where it all came from, how it all works. And as you do, I went to a bunch of conferences and I heard a bunch of talks, and at some point I started hearing people talking about vacuum decay, which is this weird end of the universe scenario where basically the whole universe could be destroyed by this like bubble of quantum death that just expands out and swallows everything. And I can get into that more later.
Hope so.
But it was a really fun talk, and I didn't know anything about vacuum decay until I heard about this, and then I started reading up on it, and it just sounded really interesting. So I started working it into my public talks, and I thought, I really need to know more about this. So I started researching kind of other ways for the universe to end, and one thing led to another, and then suddenly I was writing a book. So I've been really sort of deep into this question of how it's all going to end, and all these interesting ways for that to happen. So vacuum decay is one of them. There's things having to do with dark energy. There's sort of even more exotic scenarios. So in my book, I go through 5 different possibilities and just talk about like what it would be like to be in a universe that was ending in that way, and what you would see if you could observe it at that time, and how we know how we know what's likely to happen, how we study that as astrophysicists and cosmologists, and in experimental physics and all that. How do we get clues about what's actually going to happen at the end?
This reminds me of a time I went to the doctor and took a test and got a positive result. And I said, so I'm not going to die. And my doctor was like, oh no, you're going to die. This is not going to kill you, but you're going to die. Something will find
Yeah, that's the thing. That's the thing about the end of the universe. Like there's no scenario where we just kind of keep on going and everything's fine forever. Like that's not one of the options as far as I can tell. So it's gonna happen. It's just probably not soon. But
are there competing timescales?
Yes. Yeah. So the most likely scenario is called the heat death, and that's it's also sometimes known as the big freeze. And what happens there is, the universe is currently expanding, and so it just keeps expanding, and it's getting faster and faster in its expansion because of something weird called dark energy that we don't really understand. And as it expands faster and faster, everything's just getting farther apart from everything else. I mean, individual galaxies stay together, but they become farther and farther away from other galaxies. And then that means that you don't get new stars forming. And eventually the stars we have will die and everything will kind of fade away. And over time, you end up with a universe that's just more and more empty and dark and cold.
Looking up, seeing no stars.
Yeah. Basically.
So, but this as awful as that sounds, that's our best option, right? That's our longest longevity option.
Yeah. So that's the gentlest, most peaceful way to go. And that the kinds of timescales for that, like you get into numbers that don't make any sense anymore, 10 to the 1,000 kind of years, just big numbers, depending on sort of how you define really the end in that case. But there are other scenarios where, sometimes you can have dark energy gets a little bit too strong and starts to pull things apart that are already stuck together, like galaxies and planets and things, and that's called that's called phantom dark energy if that happens, and then that leads to a scenario called the Big Rip, where the whole universe is just ripped apart. And
I don't like that one.
No, that one would be kind of dramatic because you kind of would see it coming.
Oh wow.
But that one is like at the very earliest it would be like in 120 billion years or something like that. So there's still quite a lot of time, and probably that's not going to happen. Like there are sort of theoretical reasons why it's not favorable. And then there's like the Big Crunch, which is very unlikely because that would require dark energy to kind of turn around and collapse the universe again. So that's probably not going to happen.
That would be a fun one. I mean,
that would also be
see much of it, but we'd get closer to the other galaxies.
Yeah. I mean, we're going to get close to the Andromeda Galaxy in 4 billion years. So if you're into that, the Andromeda Galaxy is already coming for us, and that's going to be kind of cool when that happens. Yeah, but then if it were Big Crunch, then all the other galaxies would be coming for us too, and that would get kind of scary. But then there's vacuum decay, and vacuum decay is this one where basically, so you've heard of like the Higgs field, maybe. So there's the Higgs boson, which is this thing that was discovered at CERN, and everybody, there's this idea that the Higgs boson or the Higgs field have something to do with how particles got mass in the early universe. So the Higgs field is just this field, this sort of energy field that pervades all of space, and the way that like the value it has, the amount of energy in the Higgs field tells you something about sort of how physics fits together, the masses of the particles and the charges of the particles and all that kind of thing. It all kind of hinges on what the Higgs field is doing. And so right now we think the Higgs field is pretty stable, like it's not going to change drastically at a moment's notice, but there's a chance that it could. And if it did, that could lead to something called vacuum decay, which is where the state of the universe changes very quickly. And what would happen is that there'd be this sort of quantum transition that would happen in one point in space, where the Higgs field would suddenly take a different value. And when that happened, it would create this bubble that expands outward from that point. And this bubble inside of it is this different kind of space where particles don't stick together anymore, where the Higgs field is too strong and bad things are happening. So you can't live inside that new space. It's called a true vacuum. And so this bubble is expanding outward, and it has like this sort of very high energy bubble wall that would incinerate everything that it touches, and then it expands at the speed of light. So you can't see it coming and you can't get away. And then it just destroys the whole universe. And then the universe collapses. So that's called vacuum decay. And when I first heard about that, I thought that was a really cool idea. The cool thing about vacuum decay.
The really collapsing thing, though, because is that then what happened before the Big Bang type of a scenario? Like, could this?
No, well, it's a different kind of thing. So the kind of space that you get inside the true vacuum is a kind of space that is sort of just gravitationally unstable inherently, and so it kind of immediately collapses on itself. So I mean,
back together. It's just
not really. It's not exactly like. I mean, it's like a big crunch, but everything's already destroyed anyway. So, it's just kind of adding insult to injury at that point. But anyway, the cool thing about vacuum decay is that based on what we know about like the particles of nature as we've measured them with things like the Large Hadron Collider, all these big experiments, it looks like vacuum decay is like actually very possible according to our understanding of the physics of nature. Now, we know that there are things that we don't understand about particle physics, and it's very possible that one of those things saves us from vacuum decay and makes it not possible. But if we just take the standard model of particle physics as given, then vacuum decay is inevitable eventually. But that eventually is a very, very, very long time from now. So, much, much longer than the current age of the universe, trillions and trillions and trillions of years probably. But the thing is, it's a probabilistic thing, right? So it's like, it's a quantum transition. So it's just probabilities. And that means that technically it could happen at any moment. I mean, that's very unlikely. It's very unlikely, but technically it could happen right now. But it would be fine. You wouldn't see it coming. You wouldn't feel it. It just destroy everything. Nobody's going to miss you. Everything's destroyed. It's just done. So like, you don't even notice.
But
and then another good reason is to live your best life. Live your best life, everyone.
Everyone's yelling at Katie at once. What?
I know. But at the speed of light, it could already have happened somewhere in our universe and be propagating. And it's just going to take a really long time before it reaches us.
Yeah. Yeah. It could be at Saturn right now, and it'll just be a couple hours. Like, we don't know.
My question is, at the end of that, what's left?
Nothing. I mean, it's a very clean, like,
but
finish.
Where does it go? What do you mean there's nothing?
I mean, it collapses on itself gravitationally. I don't know. It sort of becomes like the whole universe like compresses in some way in this weird different kind of space.
So this
sort
is
of hard to explain.
Yeah, so this is an interesting part of the question. Thinking about these various ends to the universe, can thinking about that and studying that tell us about the beginning of the universe?
Yeah. Well, in both ways, really. Like, so if we really understand how the universe began and the conditions in the early universe, then we'll have a better understanding of what could happen toward the end. So, for example, if we really understood the very early universe, we would learn more about the Higgs field, and then we would know if it really has this instability or not. And then we would know if it's really gonna collapse or gonna decay. If we understood the early universe better, we'd understand quantum gravity. So we'd understand how gravity and quantum mechanics fit together, and that would tell us something about, the Higgs field and this instability. If we understand better how dark energy has been changing over time, then that'll tell us more about whether or not we're destined for a heat death or this big rip idea or something like that. And then there are other ideas that involve like higher dimensions of space and like collisions between universes sort of. And we can learn about those by understanding more about the early universe. And if we figure something out about, whether or not we're heading for that can tell us about the sort of structure of space on the whole. So all of these questions are really linked. And the very early universe and the end of the universe are very much connected in the sense that both of them involve kind of more like a more complete picture of physics. And so if we get a better understanding of how all of the different parts of theoretical physics fit together, that'll tell us both about the end and about the beginning, and each of them can tell us about the other.
What's your favorite end?
Oh, vacuum decay for sure.
That's your favorite.
Yeah, because it's a bubble of quantum death. It can happen at any moment. Like, how can that not be a cool idea? Excuse me.
Could happen.
I'm a little bit sick, so I'm getting overexcited. But
that's your excuse. You can stick to
it.
Okay.
Yeah.
So, thinking about different ways that it can end, and even from the beginning, you mentioned extra dimensions, and this can kind of take us into a conversation about black holes and this recent paper of yours looking at micro black holes. And I know CERN, the Large Hadron Collider, was, a lot of people were like, it's going to create these little tiny black holes and we're all going to die. We didn't.
No,
it didn't. We didn't.
It's all totally fine. Can you talk to us a bit about what the micro black holes are and what you were looking at?
So before I get into that too much, CERN, like the Large Hadron Collider, cannot hurt us. So just to be very clear, the main thing that we know, the main reason to say that is that what the Large Hadron Collider is doing is it's colliding protons together at very high energies, and so then we do that in the collider so that we can see the debris that comes out, so we can understand like how particles work. But the universe is doing that all the time. So out in the cosmos, there are particles colliding at much higher energies than what the Large Hadron Collider can do. So even if particle collisions were somehow dangerous, there would have been, billions and billions of them already happening all over the universe. And, if something was going to hurt us, it would have already done so long before we started, smashing our little rocks together. So I think I just want to make that clear, because I will talk about some scary stuff in a minute. But the LHC can't hurt us. Yeah. So the idea behind making little black holes in particle colliders is that is tied in with this idea of extra dimensions. So basically, there's this idea that the 3 dimensions of space that we experience are not the entirety of space, but there's maybe one or more dimensions, like spatial dimensions, that are kind of out there, that exist beyond the 3 dimensions of space. So just like if you had a flat sheet of paper, that's sort of a 2-dimensional surface, but you can go above or below that, and that gives you 3D. Our space might be similar, where we have 3 spatial dimensions, and then there's time. And then there might be another spatial dimension that is kind of like perpendicular to all of our dimensions, which is very hard to imagine. But if there is another dimension or several, one of the consequences of that is that it makes it easier to make little black holes with particle collisions. And that's a little complicated to get into, but basically it just means that when you smash a whole lot of energy together into a really small space, if you have higher dimensions of space, that collision, that energy being smushed together, is more likely to make a little black hole. And those little black holes, what we expect them to do is just evaporate immediately. So by this process called Hawking evaporation, all black holes lose a little bit of mass if you leave them sitting alone by themselves, and small black holes will evaporate very, very quickly. And the other thing about these little black holes that you expect in particle colliders is that when they're created from these particles smashing together, and there's always some momentum left over, so probably they're going to be zooming out of the collider as soon as they're created. So there's no reason to worry about them sitting around and like pulling in matter, because they disappear very quickly and they move very fast. But the hope has been that the Large Hadron Collider might be able to make some of these little black holes to show us that extra dimensions exist. That would be a cool thing if they do exist. And because we'd be creating these things in a collider, we'd be able to see some signature of these black holes being created. So the work that I've been doing sort of relies on that point, and then a couple of other key issues. So one of them has to do with vacuum decay, where it's been suggested in a couple of papers by other authors that if you have a little black hole and you let it evaporate, then as it's evaporating, it can cause vacuum decay. So again, we don't need to worry about this.
Isn't that the thing that we don't want?
Yeah.
It's not close.
Right. Okay. Yeah. Yes, but we don't need to worry about it with particle colliders, because again, whatever the LHC can do, space already did it, right? So the issue then is, if collisions between particles make black holes and black holes cause vacuum decay, then anytime a collision happened, even out in the universe somewhere, that would have caused vacuum decay. And so the fact that we're here means that we haven't had particle collisions in space that made black holes. Does that make sense?
Yeah. Which is ridiculous, right? Because that must have happened.
Right.
Well, so what it means is that you can't. There's a range of like extra dimension theories that don't work, because they should have had black holes being created with particle collisions, and that should have caused vacuum decay.
Haven't we done?
We shouldn't be here today to be talking about this.
Right, which means that one of these things has to not be right. Either vacuum decay isn't possible, or we don't have those extra dimensions, basically.
No, maybe not in the collider, but haven't we created these mini micro black holes before in a lab scenario?
No.
Never?
I mean, we've made like weird little analogs, like, so you can do things with like fluids and materials that kind of look like black holes in certain ways, but we've never made an actual black hole.
Okay.
It's actually really hard to do that because you need just so much energy in such a small space. So if we had extra dimensions of a certain size, then particle colliders would be able to do it, just barely. But what we've seen by not making them in particle colliders is that it puts a limit on the size that extra dimensions can be. So basically, it says that the extra dimensions, if they exist at all, have to be very, very compact. That's kind of like saying, like going back to that piece of paper analogy. Like, so a sheet of paper isn't strictly two-dimensional; it's three-dimensional. It's just the third dimension is quite small. So our universe might be like that. It might be four spatial dimensions, but the fourth spatial dimension is like less than a millimeter in size. So you could go another direction aside from the three that we know about, but you could only go like less than a millimeter, and then you'd end up back where you started. So those are the kind of limits we get from not having made black holes in laboratories. That you can only, like, the extra dimensions have to be really, really little.
Right.
And so what our paper did was it looked at the possibility of collisions of particles in the universe making little black holes and then therefore destroying the universe. And that puts a limit also on the size of extra dimensions, a different kind of limit at a different length scale, but a new one, so it's a new kind of way of putting constraints on these higher dimensional theories.
Which is interesting. And I mentioned to you before the show, we interviewed Daniel Holtz, excuse me, from the University of Chicago a few months back, and he and his other researchers had written a paper using gravitational wave from data from neutron stars to put limits on extra dimensions in space. And it sounds like it's a similar limitation in that their results were like, well, these gravitational waves suggest that there are not these bigger extra dimensions. Like, it's not like things continue to get bigger and we're just missing it. But there may be little tiny extra dimensions, but they have to be in this super compact space.
Is that the Hilbert space? Is that what that's called?
No, a Hilbert space is like a mathematical kind of a mathematical space with a certain properties. But the space that we're talking about here is just a space with four spatial dimensions. Doesn't really have a name per se, but yeah. So the paper about the gravitational waves, I was just looking at it, and they can constrain theories with extra dimensions that are something like 100 kilometers or bigger. So they're looking at a different kind of scenario than what we're looking at. So our constraints are for things like extra dimensions much smaller than the size of an atom.
Wow.
So so very, very little, very, very small, very compact extra dimensions, but in a range that kind of that's hard to reach with other sorts of experiments. So it's.
What would it mean? I mean, when thinking about extra dimensions, I mean, it's this like this, people who aren't familiar with this stuff, you think of extra dimensions, and it's like you imagine kind of an MC Escher-esque kind of kind of space where everything turns in on itself. But I'm familiar with the string theory, and the idea that there are these strings that are all wrapped up at the core of everything. But is that kind of the extra dimensional stuff you're talking about, or like how can you conceptualize these spaces?
So in this case, we're looking at different kinds of spaces where you could have either one extra dimension or several extra dimensions. So if there's just one extra dimension, then it has to be smaller than like a tenth of a millimeter or something like that, or within a certain range we've ruled out. And then if it's more extra dimensions, then they're sort of constrained to be even smaller because of both our paper and then other experiments. And basically it's like, So you have to somehow sort of wrap the dimension around itself. So we look at dimensions that are compactified, like sort of curled up in a sort of donut shape, like a torus. That's just one way of sort of curling these things up. But the basic idea is that you would have some kind of situation where if you try and go out into that dimension for a little ways, you'll come back and wrap around yourself. With string theory, a lot of the models of string theory have several extra dimensions, and they're wrapped up in sort of much more complex kind of spaces. Different something called a Calabi-Yau manifold, which is a sort of very, very complicated geometric shape that you can squish up your dimensions into. So stuff like that happens in some of these higher dimensional theories. The more dimensions you have, the more complicated that can get, because they can kind of be wrapped up with each other. But we were looking specifically at pretty simple kind of compactifications, just to put sort of the most generic limits. But yeah, there are lots of ways you can kind of try and curl these things up. And generally speaking, they do have to be small, because we do have constraints on them in other ways. And mostly these constraints come from the fact that in all these theories, gravity can travel between the dimensions, but nothing else can. And so if you have the dimensions really big, then a lot of gravity like leaks out into these extra dimensions. And then the gravity just looks a lot weaker than it would otherwise. And so by measuring gravity on different scales, you can get an idea of how much gravity might be leaking out into these other extra dimensions.
Space. It's a sieve for gravity.
Yeah, it's kind of a neat idea. I mean, the idea comes from the fact that gravity is by far the weakest of the forces of nature. So, you know that because every time you lift a coffee cup, you're overcoming the entirety of the gravitational pull of the Earth on that coffee cup. And you do that very easily with the chemical sort of, motions in your hands and stuff. And so
I like to think that means we're all very strong.
Yeah,
we are very strong. Because we're held together by the strong force and the electromagnetism and all that. And those are just much stronger forces than gravity. And so people have been trying to figure out how to reconcile that, because in theory, all these forces should somehow come from the same thing in the very, very early universe. So there should have been a time when all of the forces were aspects of the same thing. That's called a theory of everything. And we don't know how to do that. You need quantum gravity to do that. But one of the things that people have suggested as a way to kind of bring gravity, into the picture is to say it's not that it's super weak, it's that it's actually really strong. It just looks weak to us because a lot of it's leaking out into these other dimensions. So that's one way people have suggested to try to solve this problem of the fact that all the other forces are so much stronger than gravity.
That's interesting. There's a question from the chat room wondering if there is are higher dimensions, would we be able to see them?
No. So electromagnetic stuff can't get out of our spatial dimensions. Only gravity can. So we wouldn't be able to see them, but we could potentially feel gravitational signals from them. If there was something separated from us by a higher dimension of space, and there was a gravitational, a black hole orbiting another black hole in this other space, then it could make gravitational waves, and we might be able to pick those up potentially.
So it could leak back this way too.
Yeah, exactly. So if there's stuff in some other space, like for example, one idea about the sort of layout of the universe is that we're living in one three-dimensional space. It's called a brane world, BRANE, like membrane. So we're living in one brane, and then there's another three-dimensional brane, and they're separated by this higher dimensional gap. And if there's stuff on the other brane that's creating gravitational waves, then those waves could travel across the gap, and we could detect them here. So that's a thing that potentially could happen.
So here's a weird question: what if the other brane is empty, and we got all this gravity leaking into it? How do you have a universe with lots of gravity? No, nothing else.
I mean, who knows, right? I mean, we would have basically no way of knowing what's going on over there. because it's, it would be separated from us, even if it's only like a less than a millimeter away, because maybe this other dimension is very, very small. We still would only be able to detect it if we could feel its gravity. And so if there's nothing there, then we have no idea what's going on.
Oh, goodness. So I'm interested as a theoretical astrophysicist. There's a lot of time spent with equations and data and computers, and biologists from the field, have these stories from the field. And so I'm wondering if there are any stories that come up in your experience in the field that are things that you read, that are, things that you look back on and you go, wow, that really happened. Or
I mean, it's tough when you're a theorist because you're mostly like writing stuff down and coding and talking to people, and that doesn't always make for great stories. I mean, I've had some really interesting conversations in weird places with other physicists. So like I hiked up a 14,000-foot mountain in Colorado and talked to a bunch of people about dark matter on the way up, and that was kind of cool. But mostly we just kind of talk about stuff. So I do have stories from when I dabbled in experiment, because when I was younger, in my youth, I worked on a neutrino detector called Super Kamiokande. It's a neutrino detector in Japan, and so I was involved in the experimental stuff with that, and I got to go inside the neutrino detector, which is under a mountain. It's like a kilometer under a mountain in Japan, and it's this 40-meter tall tank of really, really pure water and the inside is lined with photomultiplier tubes, which are basically light bulbs in reverse. Like they take photons in and turn them into electrons and current. Anyway, so the interior of this tank, this giant cylindrical tank, is covered in these things that look like light bulbs, but like giant light bulbs, and it's filled with ultra pure water. And when it gets upgraded, people go around in little rubber boats and like fix all the machines. And I got to go into the little rubber boat and go around fixing bits of the detector, which was really, really cool. And I got to work shifts of the detector, which meant sitting in this control room under a mountain in a zinc mine for 8 hours. And every once in a while, and it was an active zinc mine, so every once in a while you'd be sitting there and somebody would come in a hard hat and yell something in Japanese, and then the room would start to shake a few minutes later. So it turned out they were doing blasting.
Oh no!
So that was fun. So I have some stories from those days when I was doing experiment. But in terms of theory, I mean, like, I guess the cool stuff is like I spent some time around Stephen Hawking when I was in Cambridge, and that was always a fun thing. He came to my talk once, which was very scary, especially because he sort of heckled, but he didn't.
Oh my gosh!
It wasn't intentional. It was like, so he had this thing that he talked through this computer, and the way that the computer could tell that he was choosing words to select to say was that it had a little sensor that would look at his cheek, and he would like sort of like move his cheek, and that would select things because he couldn't move his hands very well at that point. And so I gave this seminar once, and it was a lunch seminar, and I was up there speaking, and every once in a while I would hear like no or yes or I don't know or I don't think so or something like that from the audience, and I had no idea what he was saying. I thought maybe he was commenting on my talk, but he, like, you couldn't ask him to elaborate because it took like 2 minutes for him to make a sentence at that point because of the way that the computer worked. And so at the end of the talk, I asked somebody what was going on, and they said apparently like this little cheek sensor thing, it malfunctions when he's eating.
Oh no!
So it was a lunch seminar, and so it was just going through the most commonly chosen phrases like yes and no and I don't know and I don't think so, and just shouting them out. Like,
oh no! You're like,
It's a good thing you didn't adjust what you were doing based on that, because it would totally change.
Yeah, I mean, what can you do? I had to just kind of keep going, but like they could have warned me. They did not.
It was probably sometime around April Fool's. No,
I don't know.
Yeah. I think that's so fun. I mean, it's really what I was thinking about it before this interview tonight, that so many of our great science communicators, Stephen Hawking, Tyson, Michio Kaku, Brian Greene, you know, and I'd love to see more female astrophysicist science communicators, but I wonder if there is something about theoretical astrophysics that lends itself to communication and talking about the universe. Were you always a communicator, or did what you do on Twitter and your blog and like all the work that you do, did that come along with your career development?
So I was always a writer when I was younger. So I always liked writing stories and, you know, making stuff up and things like that. So I think it came out of that, just this sort of the need to talk about things all the time and to talk about things that I'm excited about. So once I started discovering, you know, astrophysics, I would get really excited about it. I have to tell people, you know. And so I think that all the science communication stuff just comes from like, I have to tell people all this cool stuff. But I do think that, you know, astrophysics and maybe theory in particular are especially fascinating to people, because you get these big concepts that are, you know, kind of mind bending, you know, like, I mean, I was drawn into it by thinking about things like warped space-time and black holes and all of that, you know, weird, cool stuff, you know, the Big Bang. And, you know, people like those kind of weird mind-bending ideas. And, you know, as long as you don't mind like the sort of frustration of not being able to visualize everything, or you know, these really abstract concepts, it can be really fun to go into those spaces and to kind of imagine stuff that's just so far outside of your experience and so far outside of the way you think about the universe most of the time. So I do think there's something sort of uniquely kind of weird and cool about that. I mean, and that sort of stuff happens in other fields too. You know, there are things that are really appealing about all sorts of fields, and you know, I'm sure there are things that are just equally gripping about every part of science. But I think for me, the sort of weird brain bendy stuff and the big questions, you know, like where did we come from, where are we going, how do we fit into this universe, you know, those are really fun to tackle as an astrophysicist. And I think that people are always curious about those things.
What are
it's a story in itself? Yeah, absolutely.
What are the big questions that you are moving forward on currently in your research?
Well, I'm still interested in all these end of universe ideas. So like how do we find out what's going to happen, and you know, what are the things that can give us clues? I'm also really interested in the question of dark matter and what dark matter is. So dark matter is some kind of invisible stuff that sort of envelops the galaxy and holds the stars in as they're rotating around, and seems to be the sort of framework upon which all of the structure in the universe is built. You know, all galaxies seem to have a lot of dark matter, at least almost all large galaxies. There are a couple might have only a little bit. And, you know, clusters of galaxies are full of dark matter. And so it's this stuff that's most of the matter in the universe, like 80 or 85% of the matter in the universe is totally invisible stuff, and we don't know what it's made of. And so I'm working on figuring out different ways to try and understand what the dark matter is, and you know, thinking about how new telescopes and new kinds of observations could tell us that, and what the dark matter might have been doing in the early universe, and how we're going to sort of figure that out. And that's an interesting question to me, because it gets at like what the universe is made of fundamentally, and also because dark matter is something that doesn't fit into our sort of standard picture of particle physics, and so it's got to be something new, and that might tell us something about, you know, how to fit gravity into this whole picture, you know, how to fit particle physics and general relativity together. So it's an exciting place to work.
Yeah, I think that's something I keep waiting for the information to come in on, this question of, you know, really, how does gravity fit into this picture? And
Yeah.
I keep hearing about all these studies, the experimental side of things, that just they keep supporting the standard model of physics.
Yeah,
We
standard
haven't
model
found
particle physics and general relativity. Both of them have passed every test we've thrown at them.
every test. And so the question of like all this exotic physics that people are so excited about because it would allow a lot of other ideas to come in, it's just like, well, just not seeing it yet, but
Yeah. Yeah, I mean, you know, I think it's one of these things where what we're seeing is that there are these phenomena that don't fit into the standard model or general relativity. So or you know, either one of the two, right? So dark matter is not something that fits into the standard model of particle physics. Dark energy isn't either. We're pretty sure that those things are out there. They're doing things to the universe. And so I think the question is, like, in order to figure out what they are made of, we're going to have to extend particle physics beyond what we can currently do in a lab. And generally speaking, that means going to higher energies, because generally speaking, as you get to higher energies, you tweak physics, like the laws of physics change as you go to higher energies. And so we get closer to what we think the universe was at the beginning. And in that case, that, like, we're pretty sure that everything fit together somehow in the beginning. And so if we can get closer to those energies, we can get closer to the time when everything fit together, and then we have a better feeling for how it all fits together. And so that's the general strategy that we have. And it's the same with gravity stuff. You know, we're pretty sure that general relativity, Einstein's theory of gravity, has to break down in the most extreme situations. So like the centers of black holes, or you know, in these extremely strong gravity environments, or in the very beginning of the universe. And so the more we can test really strong gravity, or gravity at very, very small scales, the more we can understand how gravity has to change to adapt, you know, to whatever the ultimate theory of gravity is. And so that's another place where we're trying to really push those boundaries.
So many boundaries to be pushed. A couple more questions.
Okay.
As a woman in astrophysics, what advice would you give to young female potential astrophysicists, women who are interested in this field? Anything in particular?
I mean, I have a whole list of advice for aspiring astrophysicists on my webpage. So I would definitely say, you know, look at that. I think that the only advice I can really give, I mean, my advice in general would be for society as a whole to you know, stop putting barriers in the way of women who want to get into physics, because women already do want to get into physics and are already there, and it's you know, there's just a lot of stuff people have to go through when they're not in the, you know, dominant demographic in any sort of field. So most of my advice would be for everybody else. But if you are a woman in physics or astrophysics, I guess my advice would be that, you know, there are a lot of nasty messages out there, and they're based in ignorance. And as society progresses, we're gonna really try and break down those barriers. So that's all I can say there, I think.
Awesome. I think that's good. And you mentioned your blog, and so that's my last question. Where can people find you online?
So people can find me mostly on my webpage, which is astrokatie.com, and on Twitter, where I'm at astrokatie. There's links to a bunch of stuff on either of those. I have an Instagram page that I'm really trying to update more often, and that's not astrokatie, that's academic nomad, because the astrokatie handle was taken,
Oh, no.
which is terribly upsetting. So you can look at those places, but basically astrokatie.com has links to a whole bunch of other stuff if you're interested. My blog and stuff are linked there.
And I'm sure when your book comes out, that's where people can
Yes.
find out.
Yeah, and there's actually there is a page on my webpage that is prominently linked from the homepage that you can sign up for a mailing list that will send you an email when the book is ready for pre-order, and it won't send you anything else. It'll just be like, here's where to make sure that you'll find out about the book.
Awesome. Thank you so much for joining us tonight.
Thanks. It's been fun.
Yeah, it's been really great. And I am really looking forward to reading your book and finding
Awesome.
out much more information about these various ways that everything's going to end.
Yeah. Before you go, can I ask one crackpot question?
Sure.
Oh, crackpot question.
What was the difference between the universe expanding and time changing? Because time-space is like the same thing. So would that be time speeding up or slowing down? I can't figure out if light's redshifting. But what would be
so time and space are connected in the sense that as you move through space differently, it changes how you move through time. But the way that the universe is expanding, the best way to think about the way the universe is expanding is to imagine that what's happening is just that it's getting less dense. So like the spaces between things it's getting bigger, and so the volume is getting larger, so the density is going down. At least the density of matter and radiation.
How's that affecting time? Because isn't it that
it doesn't? I mean, so time. Time is like the density is going down over time. So time is not like you can't by messing with time. You're not going to change.
So okay, so we're not space itself. It's not expanding. We're adding more space between space, but we're not adding more time.
Yeah.
How do we do that if it's the same thing?
They're not the same thing. They're just connected in terms of how we move through them.
So our universe is gaining space, but not time.
I mean, our universe is getting older, but it's gaining space.
Okay. Gotcha there,
Justin. Before we got the extra space. I can't do it.
And
thank you so much.
And as I get older, I wish I had more time. But anyway, once again, thank you so much for joining us. It's been just a pleasure getting to speak with you and find out about your work. Have a wonderful night.
Thanks, you too. Good night. Bye.
Good night.
Good night. All right, everybody. We are going to move on to the second half of our show. We're going to take a quick break. And as we head out, I want to remind you, you can find more information about Dr. Mack at astrokatie.com. She's astrokatie on Twitter. And I hope you're looking forward to that book like I am. Without any further ado, let's take a break. We'll be back with brains and lizard scuba and what's going on with NASA.
Can't explain things you've heard more than intuition. A lot of reason shows the way to go. New conclusion. The methods of hypothesis and patience are the only things I need. Put on a pair of goggles and go looking for the things I couldn't see.
Thank you so much for joining us for this episode of This Week in Science. If you love this episode and you want to hear or see more like it, consider becoming a patron, a supporter in multiple ways of This Week in Science. First off, everyone, if you are interested in coming to see This Week in Science live in person in Portland, Oregon, you can do it. That's right. This Week in Science will be at the Alberta Rose Theater in Portland, Oregon next Wednesday, April 3rd at 7 p.m. Doors at 6 p.m. Tickets are $15. There is a student discount, and I really would enjoy seeing you. We are going to be joined by local geeky science music wonders, the PDX Broadsides. We're going to be talking about hearing. We're going to be talking about science. We're going to be having a lot of fun, and we hope to see you at the theater. Can't make it to the theater, but you want to support TWIS? Well, one way you can do it is to support us financially. That's right. You can donate money using PayPal. If you are looking at that See This Week in Science Live in Portland, Oregon page, that's right. There are some pink buttons. You click on those and they will take you to PayPal, where you will be able to donate on a once a month recurring basis at a level $2, $5, or $10 a month. If you like the way that that works, but you're not a fan of PayPal, you can go to the top of the page and click on the Patreon button. That Patreon button will take you to our Patreon community. And in our Patreon community, you will, it's not opening, but at patreon.com/thisweekinscience, you will be able to become a patron. You click on that red button, and you can choose the amount that you support us at every month. You'll get charged once per month at whatever level you pick, $10 a month and above, and we will thank you by name on the show, in addition to other wonderful gifts that you will be sent. So support us on Patreon. Help this show keep going on a week by week, month by month basis. Help us keep doing what we do. You help us do that. Also, a way to support us is to head to our Zazzle store. If you head to our Zazzle store, you'll be able to find a bunch of wonderful items that are I can't type, you guys. What happens when you can't type? You get stuck in the middle of this little part, pop-up blockers. Oh my goodness. At Zazzle.com, This Week in Science, that's our store. You'll find a number of products that have the TWIS logo, that have art from Blair's Animal Corner calendars, and you will be able to tell the world that you love TWIS by buying our stuff, and a portion of the proceeds goes to support the show. Finally, subscribe. If you click the orange button that says subscribe at twis.org, it'll take you to YouTube, iTunes, or Google Play, the biggest places to subscribe and become a regular member of the TWIS audience. We do hope to see your support, because we could not do this show without you, and we thank you for your support.
Can't explain things you've heard more than intuition. A lot of research shows the way to go. New conclusion, the methods of hypothesis.
And we're back to This Week in Science.
Yeah, we're back, and it's time for What Has Science Done for Me Lately? Well, this What Has Science Done for Me Lately comes from David Eckerd. David Eckerd writes in to say, could not sleep at all on Sunday night, Monday morning, back itched, 5:30 a.m., went online to see if I could make an appointment. I did with my regular doctors. Their website said he had a 9:30 a.m. opening. The amount of technology behind that simple transaction from my computer, the router, the modem, hundreds or more miles of infrastructure, their server, the appointment database, its connection to the public web securely, I hope, and all the myriad of protocols needed to do that. I'd list some, but that's way too much alphabet soup right now, but it is huge and uses most, if not all, 7 of the OSI layers model. I don't know what that is. Went to the doctor, took the time to ask if the itching on the back of my skull was related, as I assumed it was. No, he uses a $64 word that I can't remember, said my follicles are infected. I walked out of there with a pill prescription for the itch. I'm not going to turn into a contortionist to apply cream to my back. I didn't even have to ask him, as he figured that out immediately. I also got another pill, and this weird shampoo for the scalp, all less than 5 hours or so of deciding to see him. Even 5 years ago, I probably would have had to spend an hour or 2 on the phone trying to get an appointment or just go to the expensive emergency room. When it works, technology is great. Science drives technology, which drives science, which drives technology, which drives. In the lab I work for, I mostly write Excel macros for them and pick up samples to get out of the house. Nearly every major machine is a robot of some sort and have been for decades. The GC machines self-inject all the samples, clean the needles, etc., all by themselves. GC is gas chromatography, and the only time you ever hear that is when someone is explaining what GC means. The cop shows do not have that right. In our lab, they have all the names. They all have names. Humans reference a name far better and faster than GC14. Are not as pristine looking, whatever. A more accurate line in the lab itself would be, yeah, we ran your sample over there on Argo, pointing to obviously used machine with a robot on top whose arms are moving occasionally. Without the robots there, you'd need 3 times the people, have 20 times the mistakes, and the mistakes, humans are not consistent and run 3 shifts a day to do what we do now. All that tech does science. And science is what leads directly to that tech being created. We have at least a half a dozen of these going all the time in our Durham office, but we print to a PDF file these days, not a dot matrix printer. So much technology, David. That was a letter full of technology, and I think this is one of those examples where, technology is getting to this point where we take it for granted, right? I mean, we still get upset if our internet ping is too slow. Oh my gosh. I can't play my video game fast enough with the other people on the internets. Yeah.
So having spent the last couple of days basically watching robots do what would have taken me a month of days to do, I can absolutely appreciate that story. Yeah.
Yeah, all of it. So appreciated. David, thank you for writing in and thank you for sharing all this appreciation of the technology in your life. And yeah, the technology, the science, the technology. Science is the endeavor, the technology is the application. If you have a story, have a sonnet, have a song, have send it. Have something you need to send related to what science has done for you lately. Send me an email, Kirsten, Kirsten, at thisweekinscience.com. Or you can leave us a message on our Facebook page. That's facebook.com/thisweekinscience. Pretty easy. All right. Are we ready for science?
Yes.
Bring it.
Thirsty for science.
So thirsty for science. Okay, so I have talked about neurogenesis in the adult human brain many times on this show, and I'm going to do it again.
Yay!
That's what's going to happen. And I love science because it's like this study does this, and then another study replicates it, and oh, we have an idea that something works a certain way, and then oh, another study comes out and says, no, that doesn't work that way. And so everyone goes, it doesn't work that way. And then another study comes out and says it does. And we go back and forth and back and forth. And really, what's happening is that limits and constraints are being put on our understanding so that we can narrow down what we do understand until we find what really works and how things really work. And this has been ongoing in human neurogenesis for a couple of decades now. Other mammals, we have found neurogenesis in the brains of mice, rats, other mammals. Neurogenesis is the birth of new neurons. And now, when I started college, I'm not going to say how long ago now, but when I started college, the idea was you were born with as many brain cells in your brain as you were ever going to have, and that they just died from there.
I remember being told that don't drink alcohol because you'll kill brain cells and you can't get them back.
Can't get them back. Nope. Well,
this is also the theory of fat cells too. Right? Like you have the set number of fat cells, and they just get filled
bigger or smaller.
Yeah.
Yeah.
Also
well,
not true.
Also not true, right? Well, so this is the question of the the new brain cells. Are they born or are they not? Because while I was in grad school, researchers came up with evidence that, oh, indeed, new nerve cells were being born in the hippocampus of the brain around an area called the dentate gyrus. Now, this is an area close to the center of your brain, these ventricles where there's blood flow coming through and there's a lot of fluid. And so it would be a place where there's interaction with a lot of uh, uh, potential factors from the rest of the body that could influence whether or not neurons are being born or not. And so that evidence has been replicated. And then this last year, another study came out that said, no, absolutely not. No neurogenesis in the adult human brain. And it was like, whoa, okay. And it was a very convincing study, even given previous evidence. Very convincing. However, we have a new study, which I'm very excited about because I like the idea of new nerve cells being born in my brain. Um, a new paper published in Nature Medicine suggests that maybe neurogenesis occurs in humans throughout life. So the researchers in this particular study did they looked at the tissue preservation process, and what they determined is that different methods of preserving brain tissue may have different effects on what we're able to see and what neurons and what cells actually get preserved or don't. So the researchers in Spain tested a number of methods from 58 newly deceased people on preserving their brain tissue. And they found that different methods led to different conclusions about neurogenesis and new neurons being born in the adult and aging brain. According to their study, the brain tissue has to be preserved very, very quickly after death, within a few hours after death, and only a limited number, specific chemicals can be used to preserve the tissue, or the proteins that we use to identify new cells get destroyed during that apoptotic, the death process. These things deteriorate and get destroyed. And so other researchers, they suggest, may have completely missed evidence of baby neurons because the proteins were dead, because the brains they got were preserved too late after death. And so, again, 58 newly deceased people, it doesn't seem like a lot, but for their methodology, researchers are saying now, this is Rusty Gage, who is a very well-respected researcher in this area. He says, methodologically, it sets the bar for future studies. From my view, this puts to rest that one blip that occurred, which was from a previous Nature paper run by a researcher named Alvarez Bula. Gage says this paper, in a very nice way, systematically evaluates all the issues that we feel are very important. So,
the one blip. I immediately thought, like, the part of the problem is getting a fresh brain, because you'll get the boop, boop, boop. Okay, take the brain. Boop, boop. Oh, wait. Boop. Wait. Hang on. Don't take this. Okay, don't take it yet. like, I feel like there's amount of time when you're still trying to perhaps resuscitate or holding out hope that might not facilitate getting too fresh of a brain.
Yeah.
It's a tough one.
Yeah. And, if you donate your brain to science, you donate your body to science. What science? I mean, there's a lot of science that can be done. And so if the people, there are people who collect these brains. We have, we've read a What Has Science Done for Me Lately from someone who takes these brains and gets them to researchers. That's what they do. How do they know how specifically to preserve that tissue so
For
that
the
it's
type
going
of
to,
research it's gonna, yeah,
yeah,
it's
I
tough.
mean, yeah, is it the way that it's frozen? Is it how what are they supposed to do? And so how do we create a better system for brain research moving forward so that we can answer questions like this?
We need to synthesize what kind of deaths occur at each hospital around the United States
Yeah.
and set up laboratories inside the hospitals. So all you have to do is run down the hall, right?
Or we just
Yeah.
need techniques that don't rely on deceased brains.
Yeah.
Right, like
Well,
the
that's
mini
the other
brain
bit,
stuff,
yeah.
but then how do you get an old mini brain? I mean, then yeah, we get it.
Well, we were talking about that last week, right?
Yeah.
It might be possible.
Might be possible. Well, moving on from the potential of neurogenesis, I'm going to keep going on the idea that yes, new neurons are being born in my brain all the time. Well, there's new research out from Australia and Germany working together. They published in Stem Cell Reports within the last week, looking at neurogenesis in the mouse brain. So, not the human brain, but we all know exercise does a body good. These researchers found that there is a slight beneficial effect to neurogenesis in the mouse brain from blood platelets. So you've heard of a blood platelet, right? Have you heard of a blood platelet? The platelets are the clotting factor, right? They go in, you get a cut, and the platelets rush in, they stack all together, and they get sticky.
They don't rush
And
it. They crawl in with
they
little
crawl
legs.
in. They do a little right. But the platelets are very important for stopping the blood flow, but they also play a very important role in our immune function and also potentially in creating factors, metabolic factors, proteins, microRNAs, other things that can send instructions to different areas of the body that they travel through. And platelet numbers upregulate as a reaction to exercise, and it is also through this study shown that at least one factor that the platelets produce was highly correlated with neurogenesis in the mouse brain.
Mm.
So there's increased blood flow, carrying the blood and the platelets to these areas of the body, like the brain. This could be one part of answering the question of how exercise not just as a body, but also the brain good.
We are not meant to be a sessile species. We are not. It's just it's very clear to me that this is a totally unrelated thing, but just in the way that my body works, mornings that I do not exercise, I need 3 cups of coffee. Mornings I exercise, I need 0 to 1. And it is this very clear relationship. Your body works better when it's moving.
Yeah.
Mm-hmm.
So this is part of this. I have a theory that we are at peak human intelligence now. Because even if you exercise after work but sit at a desk all day, you're not getting anywhere near what humans once went through. And I used to just chalk it up to, blood flow to the brain and that sort of pump of blood that was getting forced to the brain by us running all the time. But now knowing that the blood flow, which probably might even have to do with because it is based on the blood formation in the bones, but then it's also how much of this blood is transversing the body, but then it's also the nervous system, which we now know is in control of sending out these repair messages to organs and the rest of it. Yeah, this is peak human intelligence, people. We're in the information age based on a brain that was running and a body that was running like 24/7. And now it's just all downhill from here.
Oof.
No, we're not going downhill.
Instead of standing desks, we need running desks.
Oh, they've got those. They've got bicycle desks. They've got treadmill desks. They have all these things. Yes.
I want a bicycle desk. That sounds like fun.
Just don't trip and fall while you're reading, working.
Yeah, that's
well,
where
and then somebody comes around the corner of your cubicle to hand you the latest memo, and you're just dripping in sweat, and they're like, "I'll come back later."
I'm working very hard at running a marathon.
Yeah.
Yeah, but anyhow, the recent research suggests there's a lot going on, and the next step will be to find out whether or not this mouse research with the platelets and the factors that they have identified, if it applies to people, because we do know that there are exercise-induced health benefits in humans, but we don't know the factors that control that, and so this will give them a direction to look. Neurogenesis, baby! I'm all for it. Let's get it. Justin, what'd you bring?
Oh my gosh, I have a story here. Oh yes, this is the ridiculous NASA warning. Mike Pence, who is currently the vice president, I believe, of the United States of America, believes that he is smarter than the leadership of NASA. I propose perhaps he is not. But to illustrate, I will give you the words of Mike Pence, who yesterday called for landing astronauts on the South Pole of the moon within 5 years. Pence has stated that NASA needs to achieve that goal by any means necessary, although didn't explain, of course, what any of those means might be. Speaking at a meeting of the National Space Council in Huntsville, Alabama, he said that NASA rockets and lunar landers will be replaced by private craft if required, which, thanks to cuts to NASA's launch programs by the current administration, means he wants private craft to take us to the moon. It's quotey voice here. It's time to redouble our effort, which we haven't doubled for a while, but we should, if he wants to redouble it. It can happen, but it will not happen unless we increase the pace, which is true. Currently, the earliest possible landing on the moon by NASA isn't projected to be ready until about 2028. Pence then warned NASA. He says, if NASA can't put an astronaut on the moon by 2024, quote, we need to change the organization, not the mission. The space agency must transform into a leaner, more accountable, and more agile organization, and must adopt an all-hands-on-deck approach, he said. Now, to break that down a little bit, leaner means working with a smaller budget.
Yeah.
Uh-huh.
Accountable means following directions of people who have no experience in aerospace technology, which in practice will be to stop studying and communicating on global warming, which I think is ultimately the goal here. And by more agile, at first I was like, what do you mean NASA needs to be more agile? They have all sorts of different types of programs going on. But according to Wikipedia, this refers to the ability of a business system to rapidly respond to change by adapting its initial stable configuration. In other words, focus on something other than monitoring the Earth.
It's basically just another way of saying, do what I told you to do.
Do what I said, except we want you to not monitor the Earth for global warming.
Hold on.
Focus on going to the moon. Take all the money. Go to the moon.
Don't only use the money for the moon.
Why?
Only look at the moon.
Why the moon? Why?
Because it's not global warming. Just don't look at the Earth.
Really? That's the whole thing.
Don't look at the Earth. That's all it is.
No, really, he has to have a reason. Why are we going to the South Pole of the moon?
So, first of all, this is Jonathan McDowell, Harvard Smithsonian Center for Astrophysics at Cambridge. I will be astonished if this happens, noting that the lunar lander still needs to be, one, designed, and then built, and then tested to see if it's going to work, the thing they designed and built, and all within 5 years. That is a hard challenge on a 5-year time scale, even without political budget infighty stuff. So,
yikes.
Yeah.
But
Well,
why? Why the South Pole of the moon? What are they supposed to be doing there?
I think what they're looking at, this administration is looking at China has recently put a lander on the moon.
Sure.
The far side of the moon. We've got India going to the moon. These are, JAXA has, we've got everybody's sending missions to the moon, and we've been to the moon. We've landed on it, but we haven't been back since the 60s. So how do we maintain our dominance in that field? How do we keep other countries where it's still supposed to be international space, right?
Mhm.
How do we keep other countries from really having it?
But why?
So the vice president has instructed NASA. This is great. This guy with absolutely no experience at all has instructed NASA to aim to land on the moon's south pole. Presumably, I'm guessing because it's closer. He thinks, and we'll get there quicker. I don't.
It's the best place to put the space lasers.
Because
Can't we
we're-
just share the moon? Why do we have to, this moon is your moon. This moon is my moon. No? Can't we just all hold hands? on
quoting
the
voice,
moon?
the exploration of the heavens in this still new century will go forward with or without the United States, but Americans don't do second place. Americans lead, and so we will, Pence said. Yes, we will lead the world in boldly going where we have been before.
I think an interesting aspect to this too is that the budget that Trump proposed would take away funding for the space launch shuttle, the SLS,
Yes.
which would be the big mega rocket that could get us really to the moon, that could get us to Mars. This is the rocket that can give us that potential boost into space again. And that would reduce the funding for that and would require us to contract with commercial space programs, which is not
But wait a
necessarily a
second.
bad thing,
wait a
but
second.
it's
But wait a second.
limiting. I don't understand how this agileness is supposed to happen
Well,
with
this is
less
the thing.
budget.
The agility is to he's threatening, and this is not a new thing. This is also
No.
something Senator Ted Cruz has done in the past, which is try to refocus the entire mission of NASA away from part of its mission statement, which is observation, monitoring, protection of the Earth. It's the satellites looking back is the thing that they want to take out of the budget completely. They want to stop Earth monitoring. The other part of this is, how do you limit the budget of things like the SLS so that, and we're going to have a space force with no way to get up there, right? How do you limit that? But then say we want private industry to create the rocket. What pays for this? Right? I mean, that's a different budget. Why didn't you just give that budget to NASA? If you're making the thing leaner, why weren't you giving it to them? So the whole thing is the idea of putting dollars into corporate hands and limiting the focus of NASA to a less of, well, in a politically driven, less focused nature. So,
but the moon is awesome. I want us to go to the moon. That's what we've been talking about for years. 5 years is a bit soon, though.
Well, it's not. No, it's not. It's not.
We should go to the moon.
It's not.
We should put people on the moon.
It's just not funded. And it's been the thing that they keep cutting. So how do you pretend that this is your goal when you do everything the opposite of? And again, this has been
hand wavy, money shaky.
Well, it's also 5 years is when Pence will still be the vice president if there is a re-election. I'm sure that's the reason why, because he wants it to happen before he leaves office. If he's the one who's saying this. Yeah.
He's saying it because Trump told him to say it.
Sure. But it's about getting the credit before you leave office. That seems why it's this very strict 5-year timeline.
So that's part of it. That's how he gets the, I think that's more like how Pence gets Trump on board for it, to be like, you could have responsibility for this. But the reality of it is, this has been a GOP push, not for exploration of space or the moon or anything else, but, and it's all in there in that language that he used, in narrowing the mission of NASA to something like a moon landing and going away from all of the other important exploration scientific work that NASA does, which in my opinion massively outweighs dropping an astronaut on the moon.
Yeah. Understanding our planet and the science that NASA does.
Stop with the telescopes and the probes. Stop with the Earth monitoring and understanding of global warming and how climate change. Stop all of that. Let's put an fighter pilot on the moon. Woo!
Well, before we do that, perhaps we should spend some money on getting some more female spacesuits. But anyway.
Yeah, anyway. I thought that was an onion story. as we move forward. This is This Week in Science. Oh my gosh. It's time for Blair's Animal Corner.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
Do you ever hear your significant other taking care of the kids yelling, "Help me out! You're killing me here"? Maybe. Well, it turns out it's true. Females live longer when they have help raising offspring. This is from University of Sheffield. They were looking at the Seychelles warbler. They found that females who had assistance from other helpers, notably female helpers, benefited from a longer, healthier lifespan. They looked at the specific benefits of having relatives help in raising offspring because they did find an increase in survival in those individuals, and they wanted to see exactly what was going on. They showed that as parents age, they decline in their ability to care for offspring, but having helpers compensates for that effects, which allows parents to continue to reproduce. So they were able to not only survive, but reproduce for additional seasons as a result of receiving that help. So this also helps us answer the question of why some animals assist others instead of raising their own young. And it could be because there is a greater benefit of having a proven parent survive and have more offspring. So this was looking at cooperative breeding systems, which happen all over the animal kingdom. Of course, we've talked about it a bunch of times, and from invertebrates all the way up to vertebrates and humans. Of course, we have our own version of cooperative breeding systems. And that's just simply described as a situation where offspring are cared for not only by parents, but also by other adult members of the group. And the scientific name for these other members are, quote, helpers. These helpers are often, but not always, grown-up offspring from previous years. So this is where it gets interesting, is that a lot of the time they are related to the individual in question. They looked at 15 years of data on the breeding patterns of Seychelles warblers living around the small island of Cousin in the Seychelles. And they found, they looked at how quickly individuals' chances of dying increased as they grow older. But they also, this is why this particular study caught my eye, they also looked at the length of the bird's telomeres to measure their condition. So we know, of course, what telomeres do. Basically, when you run out, you're dead. So it's those nice shoelace caps that are keeping your genetic code from just fraying and straggling all over the place and falling apart and killing you. So telomeres essential to longevity. What's interesting is that in this particular species, the Seychelles warbler, the helpers, the majority of them are female, and they assist with providing food for the chicks, but also, I thought was very interesting, incubating the eggs. So the parents don't have to do as much work. The older dominant females really benefited from having specifically female helpers. They lost less of their telomeres, and they were less likely to die in each measured season. So there was a clear response, not only in the result of survival rates, but actually in this tested telomere length. What's also interesting is you only needed one female helper to show the effect of delayed aging. Just one was enough to make a huge impact on that individual. So this is interesting for a bunch of reasons. It makes sense. Help raising the kids is going to take less of a toll on an individual's body, but it also shows a great, clear reason for those helpers to do what they're doing. And like I said before, it's investing in a proven breeder that carries your own DNA with them. And those babies, if they are somehow related to you, helping them out. it's not just helping the babies themselves, which we've talked about a bunch on the show, but it's about helping that mother so that she can reproduce some more the following year.
I want to know if there have been any telomere studies between single moms, human versus married with a partner. Like, I mean, not just a partner who's working, but one that actually actively helps.
That's what I was going to say, is there's probably this spectrum if this is true, because there's people who maybe are single parents, quote unquote, but have huge amounts of help from their
family,
parents, or parents,
exactly.
or friends or family. But there's also this question of if there's a female-male link, like in the birds, are female helpers more beneficial than male helpers? But then also on top of that, this question of having somebody else, quote unquote, helping with the offspring might mean different things to different families. And it might be you could actually directly say, "You're not helping me here, Steven." And he's like, "I am helping you." And then you go and you get your telomeres tested and you're like,
"You're not
helping me." I told you. Just look at these telomeres. They're just all over the place.
My telomeres are shortening every day.
That was the problem all along.
Oh, Steven.
Huh? You think maybe that was the problem all along? You showed up with short telomeres. Not my fault. Now you're blaming me for them.
You sound like your father, Steven.
Pre-pregnancy telomere baseline needed. Yes.
Yeah. Okay. There we go.
But this is, I think it is very interesting. And, you know, the idea that the helpers are aiding not just with the survival of the offspring, but also with the survival of the mom, the parent. That's a really cool link.
Yeah. And it seems it's one of those things. I feel like every few weeks I bring something to the show where I go, this might sound obvious, but this is a new finding. And it just kind of clicked in my brain. It makes perfect sense. This is one of those situations. Of course, helping with the baby survival is also helping with the mother's survival. Of course.
Well, if there's someone else sitting on the eggs incubating, then the mother can go out and get food for herself. Well, she's not just sitting there. The mother can take some time.
She can also not be on high alert to predators at all moments because she's mobile, which is the big problem.
Reduce stress levels and
but isn't that already the language that we use? Like if you know you were to get help raising a kid, they don't go, "Oh, well, I'm going to go help Blair's kid today."
Yeah,
I'm going to go help Blair out today by watching.
Right.
Okay, right. That's, I think, more likely the language that would be used anyway. So
with humans, maybe not with animals, which is where this is a little bit different, right? As you think about how sometimes you think about an animal's function in the world, and you think about a species function, it's to propagate DNA, it's to further the genes. And so being a parent and being a mother specifically in a lot of the animal kingdom is your reason for being, is to allow that DNA package to grow up and succeed.
So the thing was, though, I was raised largely by a single mom who had a community of women who were not related, and they weren't raising to help me. They were all pitching in to help her.
Right.
And so I think in a way that is maybe more how the selfish gene, I get the idea and I get why it's beneficial as a strategy, but I think at least as humans, our friendships, our bonds between people, a lot of times go
deeper
are less genetic. Like, you might have nothing to do with your own family, but have a group of friends who would help to no end.
Yeah, we are more we are social species, and the thing here is we're looking at these species of birds that maybe they fly around in flocks, but we don't look at them as social species. we don't look at them as we do primates
Yeah,
or,
gorilla troop or something. Yeah, absolutely.
right. I mean, and we do know that there are some groups of birds, like there's some species of woodpeckers, there are some scrub jays, the eastern scrub jays, the Florida scrub jays that have this kind of setup where the young stay with the parents and help to raise. And that, the question is, it's the young staying with the parents. And so it's got to be genetic, right? It's got to be this survival value. But we don't otherwise look at most of these bird species as necessarily social, especially during the breeding season. We look at them as kind of every bird out for themselves.
Yeah, very territorial. Yeah.
Yeah, and
absolutely.
so a study like this can actually potentially start to shift the way that we think about the social structures of other animals like birds.
Yeah.
And I think what you're saying is right, Justin. Then maybe we're not looking at it correctly in the bird world.
Absolutely. But I also think there is this extra step, which is that kind of well duh moment, but is also an aha moment of, you might think that you're helping Susan over there, who's a single mom with her baby, because she's stressed out. You don't realize you're lengthening Susan's life potentially, right? Which is this extra step, this huge toll that stress takes on any body that we're only starting to explore in science.
Mhm.
That keeps coming back around. I feel like it keeps coming back around. Stress, the killer. Stress shortens your life. When you are the caregiver of an aging adult, it shortens your life. Why? Stress.
Well, let's get rid of all that stress.
Yeah.
We have to bring back Western culture is a little bit weird because we're all like, I gotta be independent and do things by
I got this.
myself.
Don't help me.
No, I don't got this. I need help. Let's build a community. Come on. Let's help each other out here, people.
Yeah. Don't you
tell
want
me
to go
about
for a nice, luxurious swim after that very stressful conversation?
I do. Get me to the beach.
Well, if you were a water anole, you might be able to scuba dive without a tank. This is a study from Birmingham University, State University of New York. And this is looking at this Costa Rican lizard species, the water anole. They can breathe underwater without gills for long periods of time to escape from predators. The record right now is 16 minutes. How do they do it? It would appear that they form an underwater respiration system that is a recycled air bubble clinging to the top of the anole's head.
That's fantastic.
It's just amazing. How was it discovered? Lindsay Swirk, good last name, very fun. Lindsay Swirk, assistant research professor of biological sciences, documented this water anole because she was studying them and they tend to, quote unquote, disappear to a predator's eye jumping underwater. And she put some camera traps out. She noticed they were submerged for a really, really long time. So she decided to kind of look further. She also noticed in analysis that lizard stomachs had insects that are found underwater in them. So they're underwater for a while. It's not just to hide from predators. They're eating while they're down there. What the heck are they doing? So she wanted to put an underwater camera under the water to watch what happened when the anoles jumped under. And it was down there for a couple of days. Saw that they appeared to be rebreathing an air bubble on top of their head. So it would kind of go back in and out and in and out right above their nose. Yeah.
It's really fascinating. I used to do stuff like this in the swimming pool with like balloons. And, you'd try and rebreathe from a bag or a balloon. inside in the pool to see how long you could go. But of course, there's that buildup of carbon dioxide that occurs after a while.
Right. So there's some combination of things happening. She hypothesizes that there is something going on with extracting oxygen from the bubble, but she also thinks that the bubbles might play a role in allowing them to get rid of carbon dioxide. She suspects there are additional air pockets around the anol's head and throat. And so the inhalation and exhalation of the air bubble allow for some trading of this air to go through this air pocket system, so that they can swap air from the initial bit over the nose with some other areas for new air.
So they have like multiple air tanks.
Mm-hmm.
That's really cool.
So she says, quote, "I suspect that there might be morphological adaptations, namely the shape of the top of the anol's head, which allow a large bubble of air to cling to it easily." So there's something going on just with the shape of their head that allows for this bubble to happen, but there's something else going on that would allow them to have this specific way of breathing where they could recirculate air in this bubble and also in these other areas. Now, 16 minutes isn't the longest time in the world. It would feel very long to us since most of us can only hold our breath for only like 2 to 3 minutes. But in the animal world, there's definitely crazier records out there. And a lot of that is because when we breathe in air, we don't take all of the oxygen out right away. And we do not use all of the oxygen in our blood every pump. So there's additional opportunity to recirculate air and blood throughout the body, which is how there are animals like elephant seals that can hold their breath for an hour. Just absolutely insane. But there's something else going on here. I absolutely love it. Usually I love to come up with some fun kind of implication from amazing animal adaptations that are discovered, but this is just the coolest, and I got nothing else to say about it.
It's just amazing. Cool. The lizard with a rebreather.
For those of you listening on the podcast who can't see, please go to the show notes. Click on the link. There's a video of this bubble appearing and disappearing over their nostrils. It is just fascinating.
I love it. Do you have any more stories? We'll go to the quick stories at the end of the show. I have a couple.
Yeah. Do you want me to finish up the animal corner with my giant T-Rex?
Yeah, get it.
Great. A fossil site in Canada yielded the heaviest T-Rex specimen ever found, estimated at 19,500 pounds. That is heavier than elephants. It is a 65% complete skeleton, which is pretty good. It's not one of those situations where there's a dinosaur with like a finger bone and they're like, we figured out what it is. So it's 65% complete. What I think is really interesting about it is that it was discovered in 1991. They have nicknamed this T-Rex Scotty. He is named after the fact that at the end of the field season, when they discovered this amazing T-Rex skeleton, all they had on hand to celebrate was a bottle of scotch. But it actually took them 20 years, basically, to uncover the remains. They were really stuck in hard rock. They were really hard to extract. So only now have they freed the bones enough to decide this thing is enormous, and they think it was 28 years old, which is extremely old for T-Rexes in our recorded history. He was really banged up. He had a broken and healed rib. He had a massive growth of bone between 2 teeth. That's a sign of infection. He had broken tailbones. Looked like it was from another Tyrannosaur's bite. So not only did he live a long life, he lived a very eventful life.
Go Scotty. Sometimes, elephants live for a long time, and those are some of the largest animals on land. And it's just hard to imagine that these giant dinosaurs wouldn't have lived for decades. They're investing so much energy into growth, but maybe it was just so hard to keep themselves fed, or
I don't know. They were supposed to be scavengers, though, right?
Yeah, the T-Rexes, yeah. Yeah, it seems just interesting to me that 28 was a young age. I don't know. Maybe it's because they just hadn't come up with medical technology yet.
Yeah, that's right. They really, yeah, maybe that's it. Maybe
No
they just fought
antibiotics.
really hard too. Maybe there was a
Yeah.
lot of fierce T-Rex competition, and they just they were constantly fighting over resources and rotting meat and space, and they beat each other up.
I always heard it because it was because they smoked heavily.
Oh, that was
Oh,
it.
right.
Yeah, emphysema got them.
Yeah.
Ugh.
Real reason the
Oh.
dinosaurs went extinct. They were
Yeah.
Oh,
all heavy
dinosaurs.
smokers.
But how did they, with those tiny arms, how'd they get the cigarette into their mouth?
Oh, the T-Rex.
Not all
the
not all dinosaurs.
The
They're like,
T-Rex smoked a pipe. That's why he could hold the pipe.
oh, a
then
very
the
long
lungs-
one. Or a hookah. They smoked a hookah. That's what they smoked.
Oh my goodness. All right, continuing on with our quick science stories. What causes hallucinations? This is a story
Well,
that
I have several answers to this.
I've talked about this a few times on the show, and most recently there was a study that came out that suggested that looked at LSD and the brain and suggested aspects of how the human brain processes information to come up with the hallucinations that we see. But the most recent study was interesting, published in the journal Cell Reports. The researchers looked at mice. They gave hallucinogens called DOI, 4-iodo-25-diamethoxy dimethoxyphenyl isopropylamine, and it really affects how the mice are able to visually see and perceive the world. And then they looked at the little mouse brains under fMRI and other brain activity. They found that the hallucinogen, opposite of what previous studies have suggested, is that the brain is filtering all the incoming information, sensory information from the world, and that hallucinogens potentially take the filters off. This study found that this hallucinogen in mice shut down the information into the visual cortex, but there were different areas of the brain communicating with the visual cortex than normal. And so what they hypothesized from their findings is that the brain gets that hallucinogens shut down sensory information coming into the visual cortex, but then the brain tries to process that information and overestimates what's actually there, thus
Just jump into
creating
conclusions.
jumping to conclusions, thus creating the hallucinations.
Interesting. Yeah.
That's interesting, but I feel like,
Yeah.
so as someone who perhaps doesn't know, it seems like in terms of what you see in like movies and pop culture about these sorts of hallucinations, they're often very unusual things that you're seeing, weird color combinations, all this kind of stuff. I wonder why your brain would choose to do that. It would make more sense for your brain to pick something familiar to jump to as a conclusion.
Well, the idea is that our perception is a combination of the sensory information that comes from outside the brain and the activity within the brain on its own. So, for instance, your dreams while you sleep come from all internal sources. And dreams are pretty weird to start with, but they're from all internal sources of information. So,
That's interesting.
our our normal perception is a balance between sensory and internal. And when you change what's coming from the sensory side of things, like with a hallucinogen, in this particular case, that could set the balance off and change the way things are perceived. And so the lack of information then gets overestimated by some areas of the brain. And so
And don't believe
that's
the
the idea.
version of hallucinogenics that you've seen in movies.
Fair enough.
Don't
It's just because
necessarily
they
believe
didn't-
everything you've seen in the movie.
Yeah, just because they're like, how do we show this? Well, let's make a bunch of weird colors merge into each other and go. That's not how it's the movie.
Yeah. And then my last story for the night, I've talked before on the show about the lamb bag. The
Oh, the lamb bag.
The lamb bag is a synthetic womb that is being created by researchers. The idea is that potentially when babies are born prematurely, that we could have a safe support environment for them to help them finish their gestation term, so that if the mother's gestational environment fails for whatever reason, miscommunication between the placenta and the mother, and the child, that we could potentially have a technological solution. And they've been studying this using sheep, and the last time we talked about it, researchers had said that they had taken late-term sheep, which would have been equivalent to very late-term human babies, and it was successful. This lamb bag was successful in supporting the babies. The most recent research on this in the American Journal of Obstetrics and Gynecology was able to support the equivalent of a human fetus at 24 weeks gestation, which is very premature. So they're pushing the envelope on this technology and getting it to a point where we may be able to support extremely preterm infants that are born at the very edge of what is currently viable, which is 21 to 24 weeks gestation.
So I guess my question would be, do you think we can get this to a point where
who needs moms, right?
No. I more mean it's dangerous, and preterm babies can often survive as is, right? So not every time, but it happens. So doing something like this with a human baby can be pretty dangerous. Would this get to the point where you could try it with a preterm baby that was so early that its chances of survival were basically nil? So there would be very little to lose in attempting it.
I mean, that's their hope. That's their hope eventually. I mean, they're starting with sheep, and eventually they'll move to I would imagine they would move to a primate species at some point before moving to human babies. That's going to be the next step. But I mean, this kind of medical support, it would be a nurturing environment, more nurturing than, what we currently use for these extremely preterm babies. And so when you have a baby that's born at 21 to 24 weeks, the health prognosis for those children is not great for a very long time, and there are often health issues that lead into adult life. And if you could offer a week or two of this kind of support, it could potentially allow enough continued development to occur in a supportive environment, or a more supportive environment, that would ameliorate some of those problems. So it'll move forward. This is the Eve Therapy Project, and it's really exciting. Justin, what do you have?
Oh, so I've often talked about the show how when somebody says something is more evolved than something else, or something's more primitive, that everything is as evolved as anything else.
Yeah.
My take on it: all life appears to have had a common origin, which means evolution, chronology, regardless of diversification or complexity, is at heart the same age from the starting gate as any other life. But there is, of course, a more nuanced vision of evolution than my own that does look at more recently emerged speciation, like humans, as young when compared to more archetypal morphologies, such as some species of fish, for instance. So fish have incredible diversity of species, as do birds, insects, and actually mammals in general. We're pretty darn diverse. Well, humans, when you get down to a set species, there's only been maybe a dozen species of humans on the planet. There could be more. Researchers trying to explain why the tree of life is so unbalanced have agreed on a few explanations. The species' ability to change color, its body size, how it interacts with its environment, all influence how quickly it can form a new species compared to other organisms, which then means you have that ability, but it's also then time itself. You know, the longer you've had a chance to do this, the sort of more opportunities you would have found. New research in the Proceedings of the National Academy of Sciences shows the passage of time has a surprising and consistent impact on evolutionary diversity and might favor young species. Cody Voice here of Pennell is one of the researchers. If groups of species were simply reaching equilibrium and slowing down over time, we'd expect more consistent pattern of slowing within every group that we look at. But the results aren't showing that. When the researchers looked at individual groups, rates of diversification varied dramatically. What they did find at the macro level is a strong pattern of faster growth of diversity in younger groups of species. Cody Voice, this really throws a wrench into how we interpret life, how we interpret how life diversified on Earth. Evolutionary biologists have tended to look at particular features that have helped particular groups of animals diversify or not. Far less explored, Cody Voice again, and potentially more interesting question is why, despite all the complexity involved in the evolution of new species, that process looks so similar across the tree of life. So it was sort of interesting, though. It was like what made me think of was the being, I don't know, kind of a one-sided. We're only comparing one side of this. So any creature undergoing evolutionary change is then opened up to new challenges in their environment and potential benefits. So brightly colored red mice may have evolved many, many times, but they're easier to be seen from above and get plucked out of the evolutionary tree pretty quickly. So you don't get to see that diversification of a species taking place from the bright red mouse on. Whereas if the adaptation is really beneficial, then you see that species. And there's something sort of interesting in that once an adaptation takes place, if you have overcome the challenges that might come with your adaptation, you're likely being rewarded by a niche that nobody else has filled properly, or you might be finding an advantage in that niche that was existing before. And so then you'll be able to grow and diversely then start expanding in different ways of exploiting that niche within the environment. So I think we only get to see the winners in that young speciation group, and I think that might be sort of why it seems weighted as quicker evolution.
But it's the interesting question too, of these younger groups of organisms that kind of have more diversification, and so there are more of them for evolution to act on. And so, maybe the question is, humans, should we be worried? There's, basically we're it for our species, right? For our little wing of the tree of life. And where's it gonna go? We're not young anymore. So yeah.
Well, when I think about it, I think about
how,
how,
my gosh, we're like the youngest. We're like one of the infants on the block, Kiki. That's what they're calling it. The young is the more recently merged, not the starting point of it. So
no, we've been around for all the since, like, I'm talking about, like, since Australopithecus, and we've been around for a while.
That's such a recent species. That's so recent. Yeah.
Well, so with the recent species having more evolutionary pressure and creating more quote unquote fast evolution, it makes perfect sense because there's less niche, there's less space to move into, so it's less forgiving. When the first sea animals were happening, it was just a big open ocean with nothing going on. So all these weird jellyfishy things and all these other things survived for a while and eventually died out, but it took a lot of time because there was all this space. When animals first came onto land, they went gangbusters all over the place, all these different kinds. But now there's such these itty bitty teeny tiny niches of nocturnal in this particular tree at this particular height, eating this particular seed.
You gotta fight for where you belong.
That you can only work in this world at this point. We're so full that you can only work if you are very good at one very specific thing where there is room for you, or if you're better at it than what's there now. So the evolutionary pressure is way stronger than it used to be.
Good points, Blair.
Mhm.
You got one more. What's a cancer tree?
Yeah, so
Yeah.
birds get it, bees get it, even occasionally podcast hosts and poplar trees get it. Cancer, which while ranking really highly on the things that suck category, can also be really, really interesting. Scientists at Oak Ridge National Laboratory have uncovered genetic overlap between genes in poplar trees that control callus formation and several human cancers. These are conserved genes of about 8 types of cancer in humans that are associated with this is chronic myeloid leukemia, breast cancer, stomach cancer, and others. That the genes have been conserved, and we split from plants a really long time ago.
Long time ago.
Yeah. But finding these genes that have been that are the same genes involved in cancers that do tumor formation are involved in the poplar trees action. So basically they think they could come up with drugs that could inhibit associated enzymes that are present and doing the work in these formations, and even block genetic pathways that trigger tumors to form in the first place. So yeah, studying
Nice.
poplar trees could lead to some cancer cures and therapies.
Well, quick reminder, you share 60% of your DNA with a banana. So,
Quick reminder. Thank you
It's just
very much.
because I eat a lot of banana. No, I
No,
don't know.
no.
you know, us and plants, it might feel like a lot of time has passed, but a lot of genetics are conserved.
Oh yeah.
So, there you go.
And that brings us to the end of our show. Thank you for joining us for another episode of This Week in Science. I would like to remind everyone, Portland show, Portland, Oregon, next Wednesday, April 3rd, Alberta Rose Theater. We have an announcement on our website with a link to where you can purchase tickets. Shout outs. Thank you to Fada for helping to promote the Portland show. He's been doing some great work flyering and letting people know. And he also helps on social media and with our YouTube show notes. I'd like to thank Identity 4 for helping to record the show. Gord McLeod and Ben Rothig, thank you for making our chat room at twist.org/live a nice place to be. And now I would also like to thank our Patreon sponsors. Thank you to Identity 4. Nope. Thank you to, who am I thanking first? Thank you to, I'm going to the bottom of the list today. EO, Byron Lee, Kevin Parachan, Mark Hessenflow, Matt Sutter, Aaron Luthen flying out, Christopher Rappin, Brendan Minish, Greg Brins, Greg Briggs, Robert Gary S., Marjorie, Rudy Garcia, Kurt Larson, Steve Leisman, Ben Rothig, Sean Lamb, Greg Riley, Jim Drapeau, Lisa Slazewski, Chris Dreyer, Brian Carrington, Jason Olds, Sean McKee, Paul, Rick Ramus, Artyom, Sarah Chavez, Ulysses Adkins, Ashish Pants, Christoph Zuknirak, Kevin Reardon, Noodles, Richard Porter, Ben Bignell, Dave Wilkinson, Sue Doster, Corinne Benton, Paul Ronovich, Andrew Swanson, Daryl Myshak, Dave Friedel, John Ratnaswamy, Stephen Alberon, Seth O'Gradney, Mountain Sloth, John Bertram, Aiden Jeff, Dave Neighbor, Brian Condren, Richard, Eric Knapp, Time Jumper 319, Bob Calder, Bill K, Jason Roberts, Matthew Litwin, Jack, Mark Mazzaros, Craig Landon, Tony Steele, Alex Wilson, Steve DeBell, Joshua Fury, Charlene Henry, Harrison Prather, Ken Hayes, Philip Shane, Stu Pollock, Ed Dyer, Richard Onemus, and Paul Disney. Thank you for all of your support on Patreon. And if any of you are interested in supporting us through Patreon, you can find information at twist.org. Next week, we will be live an hour earlier than usual. Our showtime will start at 7 p.m. Pacific. We will be live from the Alberta Rose Theater in Portland, Oregon. And we will be joined by hearing researcher, neuroscientist Allison Coffin, and the PDX Broadsides for some live music accompaniment. We do hope that you will join us for next week's show. We'll be broadcasting live online at twist.org/live. So don't worry if you can't be there in person. It will be on the internet, and that means it will be a podcast and will be available at our YouTube website.
Thank you for enjoying the show. TWIS is, of course, available as a podcast. Just Google This Week in Science in your iTunes directory, or if you have a mobile type device, look for TWIS, the number 4 droid app in Android marketplaces, or simply This Week in Science in anything Apple marketplacey.
For more information on anything you've heard here today, show notes with things like scuba systems for lizards will be available on our website. That's at www.twis.org, where you can also make comments and start conversations with the hosts or other listeners.
Yeah, or you can just contact us directly. Email Kirsten at thisweekinscience.com, Justin at twisminion@gmail.com, or Blair at blairbaz@twis.org. Just be sure to put TWIS, TWIS, somewhere in the subject line. Otherwise, your email will be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TWIS Science, at Dr. Kiki, at JacksonFly, and at Blair's Menagerie. We love your feedback. If there's a topic you'd like us to cover or address, a suggestion for an interview, a haiku that comes to you tonight, please let us know.
We'll be back next week in Portland. And we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. This week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 I've got one disclaimer and it shouldn't be news. That what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address. From stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you've learned anything from the words that we said, then please just remember it's all in your head. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. 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 This Week in 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 Science.
We're at the end of our show, not the end of the universe. We're not in a bubble quantum death. Nope, not right now. Nope, we're here on the internets talking to each other. And Identity 4, it's okay. We will record the episode there. So you don't need to worry about it. You just need to get your butt in a seat in Portland so that we can meet you in person. It'll be great. I look forward to that. I look forward to all sorts of meeting people. I have I think I've put myself under a ton of stress for next week because I invited all my friends and I've been annoying them to make them come. So it'll be good. Lots of good-hearted friends in the audience. What are you doing, Blair?
Just
Nothing.
smiling.
Just smiling. You need to get your Noki people to come.
Yeah, they're coming. I'm pretty sure.
Good.
I have a call with them tomorrow. I'll double check.
Thanks, Noodles. I've been working on trying to keep the interviews coming for the show, and I think we're all putting a lot of good energy into the show this year. And it's good. It's good. I am thinking good things. Happy thoughts about our show. I am. Thank you very much. I appreciate that. I appreciate that compliment.
I still have more questions about this whole adding space without time.
You
Still
can
bugging me.
ask those questions later.
I know I missed the opportunity again, but here's the crux of it. Why would it be so uniform? Because if things that are really, really, really far away, billion-year away galaxy that we see, billion light-year away, wouldn't it have started closer when that light started heading our way? Like, it would have been closer to us, so the shifting would be. But then same thing, but it would take longer to get here because. But then it's time.
I'm still stuck on if the entire universe was destroyed, there'd just be nothing. Where'd it go?
Right? Yes.
Then incinerated.
It can't be nothing.
Yeah.
There's so much something.
Depends on what you define as something. I guess.
Is this
I
the
mean,
whole
what is
like?
this?
This is the whole idea of like dark matter, right? Is that it's the opposite of normal matter or whatever?
Not an opposite. I
It's
know. I
not
don't
the
think
opposite.
That's antimatter.
It just doesn't,
antimatter. So
it doesn't reflect light. We just
right.
can't see or give off light.
So
we just can't see it.
Is it antimatter then that creates like just a nothingness when the universe collapses in on itself?
No, because I mean there would have
Because
to
it
be
falls
enough
apart, too.
antimatter. Yeah, there would have to be enough antimatter to
Well, there'd be no
counteract
matter to
all the
interact
matter.
with. The antimatter still existed.
That's what I'm saying.
and-
Where's all this
Right.
matter going? That's my whole question. Is like when the
Well,
universe,
matter can be turned into energy.
right?
Which
So
can be
it
broken
could-
down into disparate
So that's the
bits of-
heat death, I guess.
nothing.
That makes sense. But
Yeah.
for the other ones, I'm like, where'd it go?
But I think that's part of it also is that there's still
Magic.
like we've talked with a bunch of these astrophysicists and the cosmologists, and it's this there are still missing pieces. There are in the model of the standard model seems to be working okay, but for our theories as they stand, like there are either missing particles or missing forces that we haven't explained yet. So if we explain them, maybe that will help to answer your questions at some point.
So magic. Got it.
Yeah,
XXOBot is asking an interesting question in the chat room. So you mentioned dreams being purely from internal input earlier, but my subjective experiences say others or otherwise. Things like songs and pain have intruded into my dreams. I know this since I've woken up to the end of the song or the pain.
Mhm.
And so, but those are
Yeah.
like, we don't live internally. We have things that we bring in from the outside world. So you have experienced pain externally, or in the waking conscious life. You've heard these songs. You've heard elements that can make up a song. You could invent a song even while dreaming. But you're working off of things that have sort of been downloaded from your experiences in your conscious waking worldly self.
Or, I mean, like in this particular situation, I mean, you're looking at, you're in REM sleep, REM sleep, and it's a lighter phase of sleep, and that shifts in itself. And so you can even dream and have those dreams not have anything to do with any sensory information around you at all. Or because you're in this lighter phase of sleep that is potentially more aware of where your brain is taking potentially more information in from the outside world, it can be influenced by external sources. And so there is there can be, I mean, it's like, you hear a door slam or something that's a sound that wakes you up, right? That's because your brain is on alert. Your brain is allowing some things in. But when you're not thinking about these dreams that do contain information from the outside world, it's like what Justin said. It's this stuff that's been downloaded and it's internal and it's your brain. There's this idea that your brain is replaying events, emotions, circumstances from the day in kind of metaphorical way to help categorize it and help with storage of information.
And then in a way, it's a lot like you were describing. It's how the hallucinogen works by inferring
Mhm.
things. I recall having a dream where I had a house that only had the back wall to the house, didn't have, like, the other side of the house was just open to nature. I don't even think it had a roof. And I was sitting in this house, and there was birds flying in and out of the house because there's no wall on one side. And I thought, wow, this is a really cool house. I love this house. And when I woke up, the birds outside my window were very loud. And so and my brain had inferred that if I can hear all of these birds, my room must be missing one of the walls and it must be outdoors, because otherwise, how could all these birds be flying around my house? So it took outside information that was real, inferred what that would have to mean, and created the scenario for that to exist in the dream state.
My favorite dream inference that I ever experienced was when I had just gotten my dog. I was in high school, and my dad had taken her out into the backyard, and I guess she had gotten skunked right in the face.
Oh,
And she ran into the house and jumped onto my bed. And I started dreaming about garlic bread. And the garlic smell just started getting stronger and stronger and stronger in my dream. And I was like, this is some really strong garlic bread. And eventually it started, like, hurting my face. And then I woke up and my dog was, like, hiding on my bed, having just been skunked.
Wow.
So there we go.
Skunky garlic bread.
Garlic bread.
That's not parsley on your bread.
No.
No. All these people are going to sleep. All these East Coast people. Everyone's like, good night.
Yeah, we're losing one of the coasts.
I think
Well,
most of our
should we
YouTube
talk about
audience
next
has
week?
said good night. Yeah, but we should talk about next week.
How many stories? 2
It's
each?
an hour show.
1 each?
It's a 90-minute show, but there will be we're going to have an interview, and there's going to be a 15-minute music interlude, 10 to 15-minute music interlude.
Story. Right.
So 45 minutes to a half hour of stories. So 1 to 2 stories, 2 stories max. But what I also find that we've done in the past, when we're live, we don't I know we play off the audience a lot more and move more quickly through our discussion of things when we are live, so we can take that into consideration as
Okay.
well. And maybe, instead of talking about one story for 10 minutes, we can think about,
So
know,
bring 2,
yeah.
but
Bring
maybe
4.
only tease 1 at the
Like
beginning of
bring
the show.
4, but
Yeah.
only if there are things that you can get through quickly.
Right.
Like, it's
Exactly.
sort of
So
like all quick segment. I kind of get it. Yeah.
Okay.
yeah. So next week it'll be fast paced. We'll talk
Mhm.
about stuff. We'll play off each other. The interview, I was thinking that at the end, depending on the timing and how much time we have left, that we could also allow a couple of audience questions or something like that.
Mhm.
And then the show. And Allie was talking about, like, we could do a little fun audience participation kind of a thing
Oh yeah.
also,
Shoot, I'm
which
still
would be
supposed to do
fun.
that.
Yeah. What
Yes,
deadline was today?
Yes, deadline. I need trivia questions.
By when? By the 30th, right? Isn't that
No, I think it was, like, Monday.
Yeah, I think
Oh,
it was
no!
today. Blair, do
Yeah.
we have the trivia questions that we came up with for
Really?
Philadelphia?
Yeah. Yeah. I think I can definitely find those.
Because those are good.
So can I okay, I'll work on them
We
tomorrow, I
could also
promise.
we could also do, just a couple of questions. I'm gonna come up with a couple of questions from recent shows.
That's a good
Yeah.
idea.
So people
Yeah.
who have watched TWIS might know how to answer the question. I think this is for the listening audience right now. I think there should be a question about the transient anus.
Yeah. Should the
What
answer be the word
orifice was
anus?
found
Yeah.
to be?
Yeah. Anus!
I'll take anus for 400, Bob.
Yeah. There we go. What is a transient anus?
Oh my god, that story cracks me up.
It's so good.
No, it's so good.
So good.
So good. Yeah.
Transient.
I mean, we could ask really the hard question would be the species of animal.
That had the
Right.
transient anus?
Mm-hmm.
Yeah, it's true.
Maybe. Yeah.
I like orifice, but I think it might give it away, but people would probably say it's probably has more than one place where it has a mouth. That's probably all it is. That's got to be ears that can show up in different places. That's got to be a nose. It breathes different places. That's going to be what they're not going to go
I know.
straight to.
Anyway. Okay. Do you need me to bring my laptop?
Yes. Bring
Okay.
your laptop.
Can do.
Yeah, we should have connectivity up on stage. I am going to find out from the broadsides whether or not they will be able to actually play our intro song.
Oh, that's fun.
Yeah, and also your Animal Corner song.
Yeah.
So we may have them doing live versions. I
Oh, I love that.
sent them MP3s of the songs, and so
Oh, wow.
they're gonna practice, and they'll let me know whether or not they can perform them live.
Yeah, I
Which,
love that.
I haven't been, like, teasing that to everybody because I don't know whether they'll be able to or not, but it would be really cool. And so in that case, we may not have to cue the music ourselves, which would be nice.
Mhm.
But we should what I'd like to do is, we're gonna be up on it's a nice sized stage, and
Mhm.
there'll be a big screen behind us, and it would be nice to have like a slideshow of images
Mhm.
that we can, knowing the order of stories,
Yeah.
kinda put
Yeah.
things up behind us so that people can visualize things.
Absolutely. Yeah, and we can put the
Um,
chat room back there too.
and
I've
put the
done that
chat
before.
room.
Yeah.
Yeah.
That's easy.
Put the TWIS logo, put images from the stories, and the chat room. And I think,
Mhm.
yeah, so having your laptop to do that would be great. And then
No
I'll
problem.
have my laptop for checking up on things.
Is there any
Hopefully it'll be
reason?
fine.
Is there any reason for me to bring any of my original artwork?
Yeah, they will give us a merch table, and if you want to sell your original artwork
Do we have a
there,
price? Because it's a Patreon
you can
thing.
bring some. You can bring some. How many? But we have. It is a Patreon thing, but it could also you
So
could sell a few if you wanted.
yeah, so we should decide kind of what
Mhm.
would make sense so that we're not so the Patreon option is still the better option, I think.
Mhm.
Would make sense. But let me know and I'll bring a couple if you think it's a good idea.
Yeah, not a lot, like 2 or
Yeah.
3 or something
Yeah.
like that. And I'm gonna
Yeah.
bring a couple of calendars, and we'll charge a lower rate because it's
Mhm.
April.
Yeah. Yeah. Yeah.
Yeah, and then I've got some T-shirts, and so I'll bring some T-shirts to sell.
Mhm.
Um,
Mhm.
yeah, so we'll have a merch table. We'll share it with the broadsides, and we can sell some things.
Nice.
Maybe, yeah. I don't know how to do that. I have to bring change.
Unless you just want to use like Square. You probably have
And
time to get a Square.
I
You
have an
wanted it.
account. Yeah,
Oh, you do?
I just need to get one of those little thingies.
Yeah.
Yeah, okay, I could do that.
There's
That would
probably
make
enough
it
time
super
to ship a
easy.
Square to you, and then you don't have
Yeah.
to have any change with you. Just credit cards only.
Identity 4 wants the kiwi bird painting.
You got it.
You could bring it and hand it to him.
Okay. You want that Identity 4?
You want that?
I think you are due for another item.
Yeah.
Okay, I'll bring the
think that would be
kiwi and I'll bring a couple others.
Yeah.
How neat.
Is there anything else? Yeah, so I'm going to like tomorrow I'm going to start really like nailing down the run sheet
Mhm.
because I'm going to share it with the producer and also the broadsides so that they know when things are going to happen, like what stories are coming when and kind of the cues to be working off of, just so they have access to that ahead of time. Um, Identity 4 said, "Yay, good, okay." Um, and then yeah, so um, I think it would be great if we could have. I mean, I know you guys are traveling Wednesday, so it would be awesome to get stories in the rundown before Wednesday so we know
Mhm.
what we're looking at.
For sure.
So Monday or Tuesday,
Yep.
unless of course, something, we can always swap things out if it's like this story just came up and oh my god, we need to talk about it, and I'm totally cool with doing that, but I think we should have everything in otherwise Monday or Tuesday.
Mhm.
Yeah. Justin's like, "Uh-huh."
Just
that'd be-
pretend it's
yeah.
Wednesday on Monday.
Yeah, we can get to the moon in 5 years. No problem, Kiki. I'm on it.
No problem.
Just on
Let's
Monday, tell
redouble
yourself
my
it's
effort.
Wednesday.
All hands on deck.
Yeah.
If you can do it
Won't
on
be-
Wednesday,
Won't be
you can do
sorting it out on
Monday.
the plane. No. I'm
No,
gonna.
no.
Can you get good Wi-Fi on a plane? Not in
No.
a twin turbine.
No.
Not on the ramshackle of a plane I'll be flying in on.
Yeah. When's our Australian tour? New Zealand, Australia. I'd love to do that. That would
Oh
be
my God,
amazing.
be the coolest.
It would be so good. I'd love it. Yeah. So that'll work. The what has science done for me lately? I was thinking that we could do two things. Kai has been asking to be a part of the show. He's like, "Mommy, can I be on stage?"
Nice.
So I don't know exactly what he wants to do being on stage, but I'm like, you could do what has science done for me lately? We could get Kai to tell everybody. But
Perfect.
which would be pretty cute, I think. We could do a little quick segment to get Kai to tell us something about science or something.
Do
The
you
other
still have the fire breathing audio?
I
What's
do. It hasn't worked in a long time though. I'd
Oh.
have to spend some time putting it together
Yeah.
to make
Because
sure it
there's
works.
nothing cuter than a young person with a big
Playing with
fire
fire. Yeah.
thing. It's like a great combo.
And the other idea is to give like buy a bunch of 3x5 cards and get people to write down what science has done for them lately, and then we'll read
Oh, yeah.
people's
I like that idea.
answers from the audience.
I like that idea.
Which would be kind of good. Yeah. And that'll be a little bit of audience interaction kind of thing. Yeah. I think we're good. You guys are gonna get on planes next week.
Yeah. I'm getting on
Okay.
a plane on Friday morning, and then I'm getting on a plane on Monday to come back home, and then I'm getting on a plane on Wednesday.
Hey, busy lady.
Oh, yeah. I gotta figure out some stuff. But I always forget I don't live at an airport. I'm gonna have to
No, you don't.
get
You're gonna
there
get
and
to
back
the
again.
airport. Yeah.
You're flying out of Sacramento, right?
Yeah.
Yes.
Okay.
I think. I don't
So
know. I
I'll
haven't-
see you there.
I sent it to you.
I think.
I
Just
don't-
take a lift,
Please.
dude. Just
I gotta
take
figure
a
out when.
lift.
I gotta figure out like
Yeah.
what time the plane is, what airline. There's like all these details I'll find out when I get to the airport.
yeah. Well, I'm very
Oh.
excited. I got TSA pre-check. I haven't used it yet, and I'm gonna start. I get to
Oh.
use it on Friday. I'm
I'm
very
Yeah,
excited.
Just so you know,
Yeah.
there has been a huge spike in the number of people that have that.
Yeah.
The line is actually longer.
Yeah.
with the
Yeah.
TSA pre-check
Yeah.
now than it is on. Yeah,
Okay.
it's true.
No, it's not.
True. Yeah, they've got like 6 aisles of windy ropes you have to go through just to pass it. Whereas now, to the part where you have to take off your shoes, just breeze right through.
Yeah. Yeah.
So that's happened.
Okay. I know that's not true. No, I'm stoked. I'm
Alright.
really excited.
I know.
It's
I'm
gonna be great.
excited. I'm glad you both are coming. I'm excited to see you
Yes.
in person.
We haven't
to
done
hang
that
out.
in a long time. I think it was it the entomology conference?
Yeah, I think
So it's been like a year and a half. That
I know.
No. The San Francisco one.
yeah,
Was that the last one?
Sketchfest. That was
Sketchfest.
still over a year. That was like a
Yeah.
year and 2 months.
We should
Wow.
make sure and apply for that again this year.
Yeah.
So, I need Portland people, if you're there, I need somewhere to party on Thursday because apparently Blair and Kiki are gonna be too busy to hang out with me.
Just during the
'Cause they've, like,
day.
got grown up professionally stuff to do, and
Just during the day.
just during the day, I just need a drinking buddy or buddies for Thursday, starting about noon. Figure little pregame.
That's gonna be great. You're gonna be starting about noon. I'm gonna be like, I gotta get up and get to the conference at like
Actually, my
9
big
in the
goal is
morning.
that hopefully it's still there, the Powell bookstore.
It
Oh
is still there.
yeah.
Yeah.
I
I've
wanna
never
go-
been.
I want to go there and wander
Justin, why
around old
don't you
books.
and I go on Friday before our flight? Oh no, that's too early.
Yeah, I'll be.
What about on
still-
Wednesday before Kiki's?
We won't
ready
have
for it?
time. We'll be busy
Damn
preparing
it.
for stuff. You'll be all nerves and jitter, checking your laptop and your bag and making sure you have everything
What?
over and over again. I'll be
How
looking for my
rude.
stories, trying to put them together in time for the show.
Did you see
I'll put a
it?
placeholder. I'll put a placeholder in. I can put a placeholder in right now for the stories I'm gonna bring. But the
Yeah.
actual stories I bring will probably be between the time the plane lands and the show starts.
Identity 4 says he's gonna be around until 3 p.m. on Thursday.
Perfect.
Yeah. Awesome.
Let's go get drunk at a bookstore.
I mean, you might have to get somewhere before noon because he's leaving at 3.
Oh, I see. Yeah. This is the thing. I always have to remember.
Drunk at a bookstore. You could probably do that in Portland.
Yeah.
I do believe they have a pub. At least if it's not in the bookstore, it might be attached to. I don't know. I haven't been there for a long time.
This is frustrating because I feel like I'm still not going to get to experience Portland at all.
You've planned your trip so tightly, packed full of things to do that you won't get to see the city.
So next time, Kiki, I'm staying through the weekend next time.
Better.
I know.
No.
I had no choice. There's 250 teens coming to the zoo that Saturday, and I'm in charge of the event.
Wow.
So it was either have a quick turnaround or don't come. So I picked the quick turnaround.
Well done.
Turn it around. Turn it around.
Mm-hmm.
Oh, I'm going to be all excited next Wednesday night and want to stay up late. And then I'm going to have to get up early in the morning.
Yep.
Thursday is going to be so long.
Thursday's going to be rough. I know, especially because I have to teach a 90-minute workshop in the morning. It's not even like it's in the afternoon. I can start my day and kind of like struggle through. No, morning. Bam.
I barely get my son to school by 8 a.m. Like it's gonna be rough. We can do it. I'm gonna be so excited. We'll make it happen. I've been working for this for a year. It's all good.
You know what they say? You can sleep when you're dead. Also, screw your telomeres.
Mm-hmm.
Who says that?
People that die.
Oh, is the live show at the same time and same day? Hot Rod, same day, next Wednesday, but an hour earlier. 7 p.m. Pacific time.
Remember when we used to be at 7:30?
I do. Yeah.
But we always started at 8.
Wait, what? I don't remember this, actually.
The first 4 years I was on the show.
At 7:30? That's
yeah.
a weird time.
Yeah.
I don't remember that at all.
So there was half of the time I was in Israel, it was 5:30 a.m. And then the other half, it was 4:30 a.m. And then when I was...
That's a time change, though.
Yeah, because of the time change in Israel. It was out of sync with America. Mm-hmm. And then when I was traveling, I did it in... The worst one was when I was in London. I did the show at 2:30? I think it was 2:30 in the morning.
That's right.
How dumb.
That's early. Oh, you were so much younger than Blair.
Oh my god.
So
also,
more energy.
I was staying with my friend's family. And I snuck down to their living room and did a show at 2:30 in the morning. I don't know if I'd have the gall to do that now, to be like, thank you for taking me in. I'm going to do this for 2 hours in the middle of the night in your home. But at the time, I was just like, gotta do it.
Duty calls. Science never sleeps, people.
Oh my god. I can't believe it.
I loved young Blair.
Yeah, too bad she's dead.
Oh my god. No, she's not. She's in there somewhere, hiding.
I mean, I feel like I always had old Blair inside.
Old Blair's like, stay down.
And now the outside just matches the inside.
Stay down, young Blair. Don't get up. Don't do podcasts in the middle of the night.
No. My goodness. There was that one time I went out and then left the bar, came home, did the podcast, and then went back out to the bar.
I remember that.
I do believe I've pulled that scenario a few times. Maybe not the bar. I don't really go to bars.
Well, in Israel, they don't close.
Justin, there have been many times where you're like, I gotta go.
I got
I'll see you later.
Yeah.
It's 10 o'clock. Gotta go. I gotta pee.
11:30 and I gotta. There's the thing I gotta.
Is
Get.
that what
Thing I
that?
gotta
I always
do.
thought you were going to bed.
No.
No, never.
No, younger Justin used to like do the show and then go out.
Oh my god.
Mhm.
But I also would get off. I used to get off work like right before the show for a long time too.
Yeah.
And so I would get here, do the show, and then I would start then I'd actually be off work. Go out and do stuff.
Yeah. All those nights
then
coming in
way
from the
before
car
we would do the
dealership
show
with
in
the
the
tie
morning.
on.
We would
I
do the
8 in the
show.
morning.
Yeah. And
8 in the
I'd be
morning.
just like first cup of coffee and let's get in there. How you doing?
That's pretty
Crazy.
cool. That's neat. Then you have like your whole day ahead of you.
Yeah, but then after, that's the thing though. It's like once you've done TWIS the rest of the day, it's just not as interesting.
It's all downhill from
Nice
there.
look. Yeah, it's much better looking forward to doing the show than looking back.
I was listening to a comic on a podcast, as one does, and they were talking about how they really like doing corporate gigs because you do a show at like 3 p.m. and then you're done, and then you have like your whole night ahead of you. But when you do nightclub shows, you're like amped. You can't go to sleep. You like want to go out. You want to go get something to eat, whatever. And so like even after this, I get ready for bed and I get in my bed, but I can't go to sleep right away.
Mm-mm.
But like if you've been sitting on your couch watching TV or reading, then your brain waves are like sleep. It's much easier.
I've fallen asleep during the show before.
Yeah, well, haven't we all?
That was the 21-hour
21-hour TWIS-mageddon.
TWIS-mageddon broadcast.
Yeah.
Yes.
I can't believe I never
Justin.
fell asleep when I was podcasting from bed when it was the wee hours in the morning. I never fell asleep. I feel like I must have gotten close.
No.
Well,
No,
that's
you were
good.
just delirious. That's all.
Yeah, I really don't remember any of those. Like any of them. I do know there was one where we finished and Kiki signed off and Justin, you stayed on and my roommate got up and we ended up the three of us talking. Like I pulled out my headphones and I was using the external speakers on my laptop, and you and I and my roommate ended up talking for like 3 additional hours
Oh my
the podcast. Yeah. Because we had breakfast plans and I looked down, I was like, oh, it's 9:30. We gotta go.
Oh my goodness.
I do remember that, but yeah. And I remember people thinking that I was podcasting from jail whenever I did it from my bed with the stone behind me.
Well, yeah, that's where I've been. I've been incarcerated here for a while.
Yeah.
Thankfully, they allow me some art, I guess, and that's about it.
And then, as Hot Rod said in the chat room, worst thing would be someone getting up in their underwear to visit the fridge, interrupting you. That actually did happen in Israel because none of my roommates believed that like this was a real thing.
She's just talking to her computer.
And I think specifically the boys that lived upstairs in my suite thought that it was audio only. And so they walked down in their underwear and like poured themselves cereal in the background, I think more than once. And I had to be like, hey.
It's a family show.
They're like, oh,
Hey, I'm here doing a show. They just thought you were just up staring at your laptop screen at odd hours of the morning.
Yeah. Who knows?
Oh, God.
Fun times.
So many shows.
Oh, yeah.
So many memories. So many not memories.
I know. Well, that's earlier. Ed said like, "Oh, you made a joke about that such and such time." I was like, "That's funny. Good for me." I don't remember.
I did. What?
Oh my god, I want to find it. Yeah, he was like, "Oh, it's like that joke you made." Like, "Oh, that's pretty good." They just That's good.
I'll know it. Oh, I gotta move that. Google is using the webcam. That's awesome. All right. It's
Okay.
bedtime. It's bedtime now, so we can actually go put some memories into our brains, consolidate some information there, and come back in a week.
Yeah.
In Portland.
It's very
Goodness,
exciting.
It's awesome. It's gonna be so fun. It is bedtime, everyone. I know
In that case, you should
Bleak is
say
like I'm
goodnight, Blair.
awake morning.
Good night, Blair. Say good night, Justin.
Night, Justin. Good night, Kiki.
Kiki.
Good night, everyone. Thank you for joining us again for another wonderful episode. So much good stuff. And we hope to see you next week. Cannot wait. I'm going to try to breathe during the next week and keep my excitement moderated. I will moderate it. Good night, everyone. Dana Pearson, good night over on the YouTube chat room. Good night to our chat room. Good night, all. Have a wonderful science week. We will be back next Wednesday, 7 p.m. Pacific time, because of the live show. We will see you then.